Good morning, everyone. I would like to thank you for being here today. My name is Chuli Brkana. I'm a student in the Department of Marine Sciences here in Mytilene. And today I'm going to present you my work on the topic seagrass cover change mapping with Sentinel-2 imagery, the case of limnos meadows in North Aegean Sea. The seagrasses hold an important, complex, and productive ecosystems, which have captured the interest of many different scientific disciplines. It is important to keep them safe since they have an important... I can see my slide. Since they have an important role in the local food chain, they are participating in biochemical processing, and they are improving the water quality by forming optimal substance and giving settlements for local organisms, and also give high levels of oxygenation. Beyond their ecological value, they also have an important economical role. In the Mediterranean Sea, the most known species is Posidonia oceanica, and it is strictly protected from different directives of the European Union. And the coastal erosion is estimated at 51,000 euros per square kilometer per year. Since they have such an important ecological and economical value, it is important to keep them safe from human activity. To do so, it's important to know their exact location and to understand how they develop over the years. The goal of this research is to calculate the changes, the extent of seagrass meadows over the years 2016 to 2023. The studied area is an island in Greece, Limnos, in the northeast side of the island, because it is known that it has the largest coverage of individual seagrass meadows in Greece. In this slide, you can see the flowchart of our work. First, we downloaded the satellite data from Sentinel-2 level 2 or level 1 with 10-meter resolution. After that, we pre-processed by doing resample, subset, and mask image. Then we created control points, which way they're used in the KNN classification. The combination of the classification, the bathymetry mask, and the control points were used to do classified images and confusion matrix. Lastly, the products were imported in a GIS software calculating the area of seagrasses over the year. Let's see each step in detail. The data was downloaded from Copernicus browser from the Sentinel-2. The Sentinels were launched in 2015, which they have a 10-meter resolution. Since we're talking about seagrasses, we try to download data from each year at the same period of time. After that, we did atmospheric correction when it was needed in the level 1 data, and we proceeded with the subset and resample. Before we continue in the remote sensing field, it is important to do a mask image since it separates the land and the sea mask. So the first product is an image with an image land mask, substated and resampled. The classification methodology that we used in our research was object-based image analysis, which is based on objects and not on individual pixels. The most common classifiers are support vector machines, k-nearest neighbors, and random forest. We applied the bathymetry mask at 35 meters, since it's known that in the Mediterranean Sea, especially the Posidonia oceanica, it can be found in depths at 35 with 40 meters. So the bathymetry mask eliminates the areas that are in deeper depths than 35 meters, so we can reduce the pixels that were not necessary for this study. We proceeded by making 200 control points. Normally, in this stage, the use of field data was necessary, but since in situ measurements were not available, we used Google Earth raw data. After we combined the differences between the training points and the control points, we proceeded with a confusion matrix. We understood that the best classifier for this research was nearest neighbors, since the other two classifiers had large errors in classifying the classes. As you can see in the confusion matrix, the overall accuracy at some years were good at 94%, while others don't at 62.31%. I noticed that during the classification, the classifier had problems in identifying differences between the hard bottom and the deep sea. On the other two classes, the classification was better. In the map, you can see that it represents the stable area, which was calculated at 28.7 square kilometers, the newly established at 26.7, and the lost area 34.1 square kilometers. As you can see, in some areas, there has been an increase in the seagrass meadows, while in others, there has been a decrease. The result was expected, since many research have shown that due to the human processes, natural factors such as sea surface temperature are ruining the seagrass meadows in the Mediterranean Sea. For this research, we combined the satellite and the bathymetry data with a KNN classifier. I noticed that during this research, the use of Sentinel-2 was perfect since it had such a high spatial resolution, which means a more precise distinction. Although, if we had in situ measurements, it would give us better results. But since we did not have any in situ measurements, we didn't have the best result. But why is field data so important? Well, with field data, we can identify coastal habitats and small changes between the classes. For example, we know that in hard bottom, they live epiphyta, which means that they can be easily misclassified as a seagrass. Therefore, the lack of field data reduces the overall accuracy. Based on the calculations we did, we understand that if we substitute the newly area and the lost area, there has been a decrease since we lost 7.4 square kilometers of seagrass. Many studies like this one are highlighting a rapid and widespread reduction in seagrass areas. Such decline is attributed to human activities, impacts of climate change, sea level rise, and so on. It is important to keep those ecosystems safe while we still have the opportunity. In this slide, you can see the references that we used for our work for anyone who would like to see further on our study. Thank you for your attention. The other studies, they have also been studies for this area from different scientists, although the data that they provided was not open access for everyone. So I used only the access that I could use freely. We use the 35 meters threshold because it is known that the seagrasses cannot be found in deeper waters than 45 meters. Trying to understand, you are asking me if we can identify with a 10-meter resolution. Well, let me find the picture. This is already the image that it's a product. And as you can see here, the 10-meter resolution gave us a clear image of the 35 meters depth. And that was one of my conclusions, that I suggest in researches like this one, that the Sentinel-2 imagery, which have such as precise resolutions, are perfect for this kind of studies. Because, for example, we did not provide any in situ measurements, which was a big minus. But with that high resolution, we could even a little identify some differences in these deep waters. Well, from my research that I did, from different studies about this particular era, in the Mediterranean Sea, especially in Greece, it can be found at maximum depths of 35 with 40 meters. Because I was not sure if what kind of classes we had at that depth, I wanted to minimize the errors that we had and the misclassification. So I thought to myself that, okay, if we have 35 with 40 meters threshold, I'm going to put 35 so that I'm going to reduce the size of the wrong classification. Mhm. And the total accuracy was, well, I calculated for each year, not for all the years, because as you can see, there are some big changes. Some have medium accuracy at 62%, while others at 34%. So I stayed for each year. Yes, it is. Yes, that's a very good point. And in the numbers, I cannot tell how accurate it is. Yes. And I yeah, we can discuss it later. Thank you. And beyond their human activities, which ruin the natural processes, such as a high sea level temperature, they can also be ruining by tourism, since we know their an island in Greece is really touristic and they have a lot of tourism, which means that travel boats for tourists can also ruin the seagrass meadows. Thank you.
I'm saying this in order to find the time to feel the slide appearance.
Good morning, everybody. So this presentation will be about an application of pitch monitoring through a state-of-the-art remote sensing technique using video images. So first of all, wave run-up position and shoreline position are the two most important features in order to characterize the beach state. So to decide, for example, if we are in a state of erosion or accretion, and also to decide about the exposure to flood risk. Both parameters are important in the efficient design of coastal protection measures. They are also used for calibration of numerical models, while the estimation of annual wave run-up maximum is also a legal obligation from European and national legislation. Is the so-called Ialos line, and it forms the limit behind of which there is the obligation to establish setback zones. Both wave run-up position and shoreline position are extreme dynamic. They are evolved quite dynamic both in space and time. Therefore, topographic surveys and the satellite imagery techniques cannot provide the required temporal and spatial resolution. especially in the case of defining the Yalos line. It's almost impossible to use satellite images because during storm events, due to cloudiness, there is low visibility. So a good alternative that is widely used by the global coastal community is the deployment of camera stations that monitor constantly the nearshore. These stations are equipped with one or more cameras, a field PC where all the data are saved, and then are sent through to a server, and the rest of the work can be done in the office. Through this way, we can end up with recordings of 10 minutes for every 1 hour, every daylight hour of the day. So we can end up with 8 to 12 videos per day. So in this way, you can understand that we have an increased volume of data. All the post-processing, it can be done later in the office. Here is a flow chart of all the processes that are taking place in the field PC during each recording. The videos are broken into frames, and through some standard MATLAB routines, there's the production of optical metadata. The most important products are the Timex images, which are the average intensity of each pixel from the 10 minutes recording, and also the IMAX images, which contain the maximum intensity for each pixel. So here are our study site. It's Marmari Beach in Kos Island in South Aegean. It's a sandy, dissipative beach, which is quite touristic during summer months. The red dot in the left picture is where the camera was located on the top of a nearby hotel. And the camera was operational from November till April. So almost 6 months duration. In addition, an RBR wave logger was deployed at almost 8 meters depth. It was synchronized with the camera. So we have at the same time also the wave characteristic offshore. In addition, also dedicated field work took place, including bathymetric and topographic service and the establishment of a meteorological station. So on the left side, we have the raw image products. Then, of course, all the images were corrected for lens distortion. And then they were geo-rectified using ground control points in order to transform from pixel coordinates to geographical coordinates in a local geographical system whose origin was the location of the camera. Then the geo-rectified images were also rotated around the origin in order to facilitate the detections that took place later on the post-processing. So here about the detection. First of all, how we define shoreline and we identify actually shoreline and wave run-up on those images. Shoreline position is identified as the mean of the maximum brightness associated with the foam of the breaking waves on the SOAS zone, and it's detected on Timex images, while the wave run-up position is associated with the maximum and most onshore location of the brightness associated with, again, with the SOAS zone. So for the detection of both features, an automated detection algorithm was applied that has been tested also in past studies. For the detection, there is the usage, the application of a kernel element that it starts from the one edge of the feature of interest, either the wave run-up extent or the shoreline position. And it walks along the zone of high brightness. And for each longshore location, it detects on a predefined window, it detects the feature of interest and walks to the next longshore position. Here I have. Okay, I'm sorry for that. I had a video, but to show the evolution of the detections. Να το έχω κι άλλο πίσω. Ναι. Okay. So I'm going to present directly the next slide. So here we focus on the wave run-up variability during the recording period. We can see the second diagram. We have with the red line shows the maximum differences between the detection for each longshore location in the study area. We can see that we have the highest variability in the western and the central part, while the variability is highly decreased on the eastern sector. And we defined the 12 transects that you can see in the first plot in order to study the variability. First, we focus on the western sector, on the most left transects. So on the third plot, we compare the hourly detections with the first detection. On the bottom plot, we have also the time series of the wave height, as it was recorded from the RPR. We can see that we have a maximum wave run-up extent during the most energetic events, that the wave height was equal or higher than 0.7 meters. What is interesting is that in some calm periods between storms, especially during the end of November, there was high variability on the wave run-up between the different longshore locations. This it can be attributed to a lot of reasons. First of all, is the dissipative nature of the beach that is characterized by the presence of a longshore bar that affects the wave transformation. It can also be due to a groin that acts protectively on the western edge, and maybe also due to a small stream that ends up on the western edge of the beach. Here we go to the eastern sector of the study area. We can see that there is less variability, and the most offshore wave run-up position is mainly associated with lowering of the mean sea level during January because of low tide and also high atmospheric pressures. Apart from that, we can see again that the highest value of wave run-up positions are again associated with the maximum wave conditions. So to conclude, first of all, we can see that beach optical monitoring system is a fast and powerful beach monitoring tool that allow us to decide about the morphological state of the beach, and also it can enable us to estimate accurately the Yallo's line, the SWAS maximum limit. There were higher variability of SWAS behavior on the western and central sector, and this was attributed both to the local morphology, but also on the growing on the western edge. The eastern sector appears more stable. This was shown not only by the wave run-up, but also from the behavior of the shoreline, while the elevation of the camera was 10 and 11 meters high, so it didn't allow to monitor better a longer stretch of the beach, because after 600 meters distance from the camera, the resolution ceased to be that good to produce reliable detections. So thank you very much. Yeah. Yeah, actually, they were performed a bathymetric survey with a single beam in the beginning. It's a quite shallow area, and with the presence of a sandbar between 1.5 and 2.5 meters depth. Yeah, for sure. Yeah, because maybe if we could have seen the video, you can see that during energetic conditions, you have a pattern of wave breaking also on the location of the sandbar. So you can see there also how it affects the wave transformation. And you can see actually also how the location of breaking waves is moved onshore and offshore. Follow-up on this question. And the follow-up is, so basically, you understand that there's a lot of variability and common this is because of changes in the near-shore bathymetry. If you want to continue to this, on this track, i.e. to find out a little bit more information, why is that and what are the further mechanisms so on, what do you propose to do? There are a lot of stuff that you can do. From my point of view, you can either try to apply some depth inversion algorithm to have some estimation of the depth through the video images, like Holman and his team has done in the past. Then, of course, the first one is to study the location of the sandbar better from the Timex images to see how they move onshore and offshore. Yeah, and then of course maybe some more careful study on the on the SWAS dynamics in the SWAS zone using the ADV measurements that we took in the last day of the recordings, and also using some time stacks in some longshore locations.
Other questions, please?
Okay, this is the talk I'm going to present today is about a very classical problem, a very classical, and the solution of this problem is also very classical. But what I'm going to show is just maybe a faster and shorter, maybe a little bit more elegant way to approach it. We all know what upwelling is, the mechanism of wind-forced upwelling. We have two kinds of upwelling. We have the upwelling that is caused by wind stress currents. I have a short example here where the wind is like this. You have the wind blowing, coming towards us on this side. So we have the divergence at the surface and the resulting lowering of the surface on the upwelling. Oh, yes. Yeah. I'm sorry. Yeah. So to the left, we have a classical example of coastal upwelling, of offshore upwelling, what is called the Ekman pumping. While to the right, we have the so-called coastal upwelling, where the wind does not need to be to have any vorticity. So the horizontal divergence emerges from the presence of land. So what the traditional approach of oceanography to this problem is to isolate the longshore component of the wind. And then there are several ways of estimating upwelling indices, like the pressure difference, the air pressure difference determining the longshore component of the wind, or the wind stress along this component, and so on. However, if we notice that we can simply, while for offshore, for the offshore upwelling, we estimate upwelling by estimating the upwelling velocity at the bottom of the Ekman layer through the vorticity of the wind stress. During when we assess upwelling, coastal upwelling, we just take the longshore component of the wind. However, there's another approach that we can follow. It is just by setting the wind stress equal to 0. If we do this, then the divergence of the Ekman layer, the Ekman transport below land will be, of course, 0. So the divergence of the Ekman layer is exactly what it should be using just the longshore component. So we can use exactly the same formula as in the case of Ekman pumping. So this is what this work is about, and this is what we are going to apply to the GNC. And here we show to the left the estimation of offshore upwelling, of Ekman upwelling, based on the vorticity of the wind field using ERA5. And to the right is the total upwelling, which means the offshore upwelling plus the coastal upwelling using the wind stress set to 0 over land. So one thing that we notice, first of all, is that coastal upwelling appears along the eastern shores of the GNC without considering the coastal upwelling assumption. So actually, we get coastal upwelling just by the divergence of the wind. Why? Because we have the vorticity induced on the wind field by the orography of the mountains and the islands of the GNC. So we can get coastal upwelling just by using the regular Ekman pumping, let's say, math. And then we can get intensification of coastal upwelling nearer to the coasts when we apply the, let's say, the coastal approach, the coastal upwelling approach. And then, of course, we have some additional intensification areas by using that. And this This estimate is for a climatology using ERA 5 from 2000 to 2019. Also, I should stress that these are annual values. So we get coastal upwelling is not present only summer, and this slide is referring just to summer upwelling, but it is present there also very strong in the winter, and we'll see that later. If we look at the time series, we isolate now the upwelling from the downwelling regions, because here with blue, we see the downwelling regions that are related to this process. And here we see that we have that overall, it seems that coastal upwelling, not coastal, the total upwelling, overall is higher than the total downwelling. And these are dominated by the annual cycle. However, if we take the difference, a semi-annual cycle is introduced. Also, when we're looking just the upwelling or just the downwelling, the cycle peaks in winter, not in summer, as we would expect from just observing SSTs, for example. It's just that in the winter, due to the large homogenization of the water column, we don't see it. In the summer, it's very obvious in SSTs. Now, the funny thing is, when I started playing with it, I thought that since we saw the overall upwelling, as you see here, this is the flux. So this is integrated over the whole region to see what happens over the whole region, right? And then I noticed that if I apply the Stokes theorem, I'm not going to explain the Stokes theorem because we don't have much time, but this is actually the surface area integrating the vorticity of this vector over surface area equals to the line integral along the boundary of the vector itself. So if we replace this by the Ekman dynamics factors, which is actually the vorticity of the wind over the density and F, the frequency, the Coriolis parameter, then we have the horizontal integral of the vertical velocity equals actually to the Ekman transport, the integration of the Ekman transport, here there should be a dot product, over the boundaries of the Aegean, which actually are the boundaries along the Cretan Straits. Which means that we should be able just to, instead of actually integrating through that, just to estimate the Ekman transport through the straits. And this is actually, physically, it's very natural, but it's really elegant how it comes out from the math. Also, it's very impressive how the fields change when we use high resolution wind fields. This is the ERA 5 wind field, which is 1/4 of a degree. And this is the Cosmo, I think it's Italian Air Force Meteorological Service, the wind field. And we get very high frequency, high wave number, I should say, variability of upwelling at the lee side of every island, and also at the lee side of the 3 major mountains in Crete. So when we test the application of the Stokes theorem, the black line here is the net upwelling estimated through the horizontal integral of the vertical Ekman velocity, while the red line is the sum of the Ekman transport through the straits. And we see that actually they fit very, very well. And I should say that this calculation has been done for Cosmo, for the high resolution data set. If we use the low resolution data set, there is not such a good agreement, which means that we need high resolution winds to actually try this approach. And I hope, yes, I reach the conclusions in time. So coastal upwelling can be incorporated in the traditional Ekman pumping approach by setting the wind stress over land set to 0 and just use then the vorticity of the wind field. And that way we do not need to estimate let's say, make assumptions about what scale we need to assess the direction of the coast and isolate the alongshore component and so on. And we don't need to estimate upwelling indices because we can just use the Ekman velocity, the Ekman pumping velocity at the bottom of the mixed layer. But one other interesting thing is that if we integrate, we have a basin. And we see that the basin can overall, due to Ekman pumping, export or import water over many years through the surface. And then that means that it actually may affect also the thermohaline functioning, because that may account to buoyancy input or export at the straits. So this is one other thing that we can take advantage of and play with. So thank you very much. Oh, no, actually, look.
But also the people that are studying the changes through the strains. Yeah. Congratulations. Yeah, like biogeochemical
Well, remains to be observed. I really don't know. I mean, first of all, we need to assess, to check SST, very high resolution SST fields, to see if they are also mapped at the same high resolution, the small scale features, if these are also observed there. And then, of course, after we see whether this is actually observed in SSTs, then we could start to look for biogeochemical effects. But, first of all, I should say that upwelling in the Aegean, based on our other researchers in the past, seems to come from 35 to 40 meters, not deeper than that. So that means that since the Aegean is very, the water is very clear, the nutricline is deep, is below 80 meters. So there is no strong impact in general of biogeochemistry.
So it might keep the water a bit cooler in some places, which may be more suitable for seagrass.
Yes, and also for swimming. We should take that consideration.
But the only effect beyond the acid exchanges and the case of the carbon dioxide can be some impact. But like primary production, the nutrients are too low, and the nutrient is too big. So the temperature, maybe the temperature difference affects this habitat.
Yes, but now I really get the point. I think you're right. Maybe we can see the difference at benthic organisms, at seagrass distribution and stuff. That's a very good idea. Yeah.
Any other questions?
What don't?
Sorry.
Yes, very interesting. Obviously, most of it is not theoretical or robotic. You mentioned the SST, that is some kind of localization. Can you imagine any other way of trying to get some information and verify the study?
The heat fluxes, that could be, it's not to verify the immediate impact that it would have on heat fluxes is where what we want to look after that. I mean, this is the immediately after following work will be the impact of on the heat fluxes. But to verify that is not easy because SST is determined not just by upwelling and downwelling, but also through wind stress to the cubed, the vertical mixing it causes, especially in the summer. So the signal has many different sources the temperature changes. So it's not easy to isolate through SST. But the next work will be looking at the fluxes. Yes, these calculations we have done were based on the coastal upwelling west of this island. Yeah. But this is also the strongest signal that we have in summer. Maybe in the winter it may become from deeper depths because we have lower stratification. We have not looked yet what happens in winter. Yeah. Yes, Bob's idea was very nice to look at the benthic populations.
Hello, everyone. So now we will be looking on the effect of the sea breeze on the air-sea heat fluxes of Colony Bay here in Lesbos Island. For anyone that knows the island, knows that the Colony Gulf is the biggest out of the two that this island has and is of great geographical position and has a lot of anthropogenic activities. So it is of great interest to us. It is one of the most productive semi-enclosed coastal basins in Greece and has an ever-growing agricultural production, fisheries, and is of touristic interest. To add to, it has also ecological value because it's habitat for a lot of species and some migrating birds as well. To add to the value of the bay, the Department of Marine Sciences here in the University of the Aegean has installed a coastal environmental observatory which supplies us with atmospheric and oceanographic data in real time. Let us now look into the data sources. So we collected data from February of 2020 to November of the same year. There were both atmospheric and oceanographic variables. You can see both the instruments that were installed in the mooring and the mooring as well that we have in the Colony Bay. Some of the atmospheric variables were wind direction and speed, relative humidity, and the air pressure and temperature. And the oceanographic ones that we used for this study was the seawater temperature at the surface. We have to note that the atmospheric instrument is installed 3 meters above sea level, and the oceanographic one is installed 4 meters under the sea surface. This was taken into account when we were doing our quality control and analysis process. Now let's get into the data processing and especially the wind analysis. So we want to calculate the effect that the sea breeze has on the heat fluxes. So our first priority was to identify the days with minimum wind speed and exclude all the other days that have a large-scale atmospheric systems. The criteria that we set, the limit that we set for the wind was 3.3 meters per second. We came to some results. First of all, you can see in the histogram that we have an increase of the wind speed during late morning to early afternoon and a decrease in the evening. From Rose diagram A, you can see that, you can see that the direction of the wind aligns with the geographical main axis of the bay. And we also have southwestern winds during the day that originate from the mouth of the bay, as you can see in the second Rose diagram. So having identified the days of weak large atmospheric conditions, we proceeded with the estimations of the turbulent heat fluxes. We used the data from the mooring as input for these parameterizations. We used the standard calculations from Ferrol et al. So our input was the wind speed, the air temperature, and the sea surface temperature. We also used the relative humidity data we collected from the mooring to calculate the specific humidity of the air and the sea surface temperature to calculate the saturation-specific humidity at the sea surface temperature. So let us now get into the first results that we have. Here you can see an average daily cycle for each month of the examined period. With orange, you can see the latent heat flux, and with blue, you can see the sensible heat flux. The first thing that we noticed is that throughout the period under examination, the strongest heat loss is due to the latent heat flux. The sensible heat flux is 1 order of magnitude smaller, and there are several months of the year that we can see a heat gain from the atmosphere, especially during the warmer hours of the day. So from February to April, you can actually see that the latent heat flux is almost constant at around 50 watts per square meter, but we noticed a slight increase of about 15 watts per square meter in the warmer hours of the day. However, in May and June, we have they are characterized by a strong diurnal cycle of the latent heat loss, increasing by 100% during the day compared to the nighttime values. In July, August, and September, we have the highest value of latent heat losses that are estimated throughout the day, reaching up to 200 watts per square meter during the warmer hours. When we reach October and November, we can actually see that we are slowly going back to the conditions similar to those in the spring months. The sensible heat is strongly dependent on the temperature difference between the atmosphere and the seawater, as you saw in the previous slide. And a sensible heat gain appears to increase when warm and dry conditions prevail, especially you can see it during the months of July and August. So during the days that passed the wind criteria mentioned above, locally induced winds result in an increase of the evaporative fluxes up to 100%, revealing we have a significant effect of the diurnal cycle of the local small-scale winds of the heat fluxes of this bay. This effect, the sea breeze, the local sea breeze effect is stronger during spring and fall. Actually, during summer, we noticed a bit of irregularities in the diurnal cycle of latent heat flux, maybe because the transport of drier masses becomes the dominant factor this time of the year. This preliminary analysis indicates that a fine-scale effect may have a strong role in the local heat fluxes and can be easily overlooked if we have larger scale forcing used for the forcing of this kind of basins. So as operational oceanographic efforts slowly but surely move from regional scale simulations to the coastal regions due to their ecological, social, and economical value, the present work may constitute evidence that a successful simulation for the coastal processes maybe is a new challenge for the modeling community. To improve this assessment, we need a very high resolution modeling for both the ocean, the atmosphere, and their interaction, even at local scale. So to conclude here my study, I have also to note that recent hydrographic measurements in Colony Bay, which were implemented by the framework, by the project AGS Plus, revealed that during the summer, the bay behaves as a concentration basin, which means it exports high dense water in the Aegean Sea. So by using low resolution atmospheric forcing to simulate the circulation and forcing for this kind of bay during the transitional seasons, it may lead to an underestimation for the latent heat losses and eventually the exchanges that it has with the open sea, and an overestimation of the resident times of the water in the embayment. The work is not done here. We actually plan on calculating the total heat budget, including long wave and short wave radiation, which the mooring has also instruments collecting that. So we have real-time data from the same position from the mooring of Colony Bay to continue our study. Thank you for your time. Thank you.
Now the oceanographic session will interact for some time. I remind you that at 1 o'clock we have the type of by at the large amphitheater, and that is 3:30 we convene to the at the large amphitheater.
Ο τίτλος.
Okay. Good morning. Thank you for participating in this keynote speech from Dr. George Rigos. He's going to talk about modern and environmentally friendly antiparasitic treatments in aquaculture. Dr. Rigos is a research director in IMBBC HCMR, head of the Pathobiology and Pharmacokinetics Fish Lab, and thematic topic is on aquaculture, the talk. His PhD is in fish pharmacology. He has a total of more than 25 years of research experience in various themes, mainly including fish diseases, therapy, and fish safety, and the assessment of an environmental burden from drugs used in fish medicine. During this period, he has established a strong collaboration with the industry locally and abroad, particularly in the field of consumer and environmental welfare. He has managed as coordinator of Scientific Principle 7 and participated in 32 projects in several research projects, as you understand, funded by the European Union and national sources. At the same time, he has written 77 publications in prestigious international scientific journals. Impact factor, for example, 296, H-index 29, etc. He is also the author of book chapters on consumer safety, legislation and therapy, and fish pathology, while he was awarded as International Scientist in 2007-2008 from the International Biographical Centre of Cambridge, England. His participation in international scientific journals involves editing roles and reviewing tasks, more than 100 evaluations in 28 different journals. During his scientific career, he has been involved in the evaluation process of 9 researchers and professors and of 7 European international projects, centrally or remotely applied. He has also supervised and co-supervised 4 PhD students, 10 MSc students, and 1 BSc students. His academic expertise also includes invited speeches and lectures in graduated programs hosted in national or international level. Dr. Rigos, please, you can have the stand. Thank you very much.
So, good afternoon. Thank you for joining this session. I know that the beauty of the island and the Greek nice weather are very tempting. My name is Giorgos Rigos, and I'm a researcher in the Hellenic Center of Marine Research. I've been involved with aquaculture in almost 3 decades. A few years working in the field, but mostly doing research in several aspects, mainly including fish safety and pathology, pharmacokinetics and therapy, and interaction with the environment. I want also to thank the organizing committee and the president of the Congress for the kind invitation. Today's talk will be on modern and environmentally friendly antiparasitic methods in aquaculture. So there will be this is a brief outline of the talk. There will be an introductory part, followed by a presentation of the main antiparasitic method used to combat fish parasites in aquatic medicine. The third section will be on the delivery of these compounds, and the presentation will be closed by a small discussion on the interaction of treatments with the environment. All primary production industries, including aquaculture, are vital for the financial wealth of any country across the globe. But aquaculture in Greece has a historical position, emerging during the 80s with enormous growth, and also offering numerous jobs and providing a healthy, cheap, and high-quality product from the sea, while at the same time was contributing significantly to the export market of Greece. And although when aquaculture emerged, it was accompanied with continuous growth, during the last years, its production is more or less stable, but has reached high production yield, which is more than 130,000 tons. This is translated to 744 million euros. The leading species is, of course, Gillhead sea bream, followed by sea bass, while remaining small part is covered by other species, mainly meager and red sea bream. What is important to state is the fact that aquaculture in Greece is more than double than that coming from fisheries, which is an indication of its high value in the market and its compensating role against the reducing fisheries catches. This is the profile of the global production of aquaculture. We can see that's a different pattern compared to the Greek one, since we have a continuous growth in all subcategories, including fin fish production from marine and freshwater environment, crustacean production from both environments, production of mollusks, production of other aquatic animals, and of course, algal production, which has become very important lately. The global production of aquaculture is around 88 million tons, which is below cattle, which is above cattle, but below swine and poultry production. But what is important about farm fish is the ability of the animal to utilize feed and convert it to meat. This is usually expressed as the feed conversion ratio. That parameter was analyzed yesterday by my colleague Yannis Karakostas, and these values in fish range from 1 to 2, although there are some occasions with herbivore farm fish where we can find even values below 1. Similar values of FCR to fish we can find in poultry, as opposed to cattle and swine, where this parameter is several folds higher. So small FCR reflects less loss of energy, of feed, and of money, probably indicating a high profitability margin for aquaculture enterprises. But we know that that's not always the case, since there are so many other factors involved in this equation. Fish farming remains a significant export asset for the Greek economy. In this figure, we can see the major Greek export sectors, where, of course, the leading position has been taken by fossil fuels, followed by industrial materials, and in the third place, we can see food and animals and all agricultural activities, including aquaculture. And after, we have other important sectors like machinery, oils, and so on. In the second figure, we have the Greek exports. Subsectors participate in all agricultural activities. We can see that fish have a leading position with export value more than €500 million, which above olive oil, but below cheese and fruits and vegetables. But what we don't usually do when we are proud and we claim about our fish exports is we don't estimate the amount of money spent to import raw materials to prepare diets to feed the fish. So it will be more accurate and realistic when we do this equation to balance between fish exports and money loss to import raw materials. Aquaculture, as all primary production enterprises, suffers from parasitic pathological problems. And it has been calculated that the financial damage only due to parasites in global level is more than €12 billion, which is quite a high number. A characteristic example is the case of sea lice in Atlantic farm salmon. Sea lice have been a nightmare for farm Atlantic salmon since the 70s and still remain probably the #1 problem among so many other disease issues. In Norwegian Atlantic salmon, the damage related to sea lice, and this coming from therapeutic cause and direct mortalities, is now not less. It's above €1 per kilogram of fish, which is quite high. To state here that all salmon producing countries are facing issues with sea lice, including Chile, which is the second world producer. Another example, it's much more closer to Mediterranean and Greek aquaculture, is the case of the gill fluke, Sparicotyl Christophe in farm Gillhead bream. This is a very important pathogen for sea bream, and due to its high importance, we'll meet this bug several times during this talk. So mortalities due to Sparicotyl are more than 30%. And there are also other indirect problems like reduced fish biomass and increase of FCR, which indicate feed money loss. This is a list of the main ectoparasites of Mediterranean farm fish. Although European sea bass is a farm species which is more susceptible to bacterial pathogens, there are some worth mentioning parasites, including the isopod Ceratophrys raides, the Copepillanthropus, the Monogenia diplectanum. On the other hand, Githylus cibrim is clearly a farm species which is vulnerable to parasites. We stated the importance of sparicotel in the previous slide. There are also some protozoan parasites that cause losses in cibrim in land-based facilities like the flagellate amylodinium and the ciliate cryptocaryon. Problems due to parasites also observe in new farm species like in Meager, we have two monogenians, Benedina and Cyanocotyle. And of course, the case of Zoozapta in greater amberjack, which can be very catastrophic in a cage environment. We can move now to the second section of the presentation, where we will discuss the main methods used to confront fish parasites in aquatic medicine. Genetic selection is a very important strategy which has been used for several decades in salmon farming, and more recently in Mediterranean management. With broodstock selection, we can produce progeny that can be resistant to a specific pathogen. Fallowing is a method that is widely used in agriculture and some aquaculture activities abroad. By doing fallowing, we can move our facilities, our cages, for example, to a different spot which can be more pristine in order to break the parasitic cycle. I suppose that in Greece, due to space limitation, this method is not very applicable. Vaccines and immunostimulants. Unfortunately, there are no commercial vaccines for fish parasites as opposed to bacterial pathogens, but there are some immunostimulants that can be used to seal the defense system of fish. The biological tool is a very important weapon for killing parasites, but it's exclusively used in salmon against sea lice. The use of cleaner fish, there were some ideas in the past to use the Mediterranean wrasse against lice of sea bass, but these ideas were kept in the drawer. The use of chemicals, the most widely applied aggressive and effective method. Functional diets, also a significant addition to the battle for parasites, which is of course harmless to the environment. Another group of therapies that also do not cause any side effects to the environment is the use of natural compounds with hydrogen peroxidase and hyposaline baths. And of course, the state-of-the-art mechanical therapies, including the use of laser and on-board thermal and freshwater treatments to, again, to kill sea lice. The first group of therapies that we'll discuss is the chemical antiparasitics. The problem here is the limit availability of registered compounds, especially when we compare to antibacterial agents. Norway is always the exceptions, simply because the Norwegian government is probably more flexible, more open to registering new chemical drugs to confront sea lice. In several European countries, there is only one antiparasitic compound registered, and this is usually formalin, while in some others, there is no antiparasitic registered. Fortunately, there is the option of off-label use. This is a guideline established by the European Medicine Agency that provides us the ability to use a registered antiparasitic or antimicrobial compound from other farm animals, for example, from livestock to fish. This is a very bureaucratic process, and enforce the use of 500-degree days withdrawal time just to ensure the safety of the consumer. This table has the list of legal antiparasitic compounds in Europe. The ones that are in the light blue, they are fully registered antiparasitic compounds. There you can find all kinds of information, including the source, the administrator en route, the dose schedule, the target phase and the target pathogen, the commercial name of the product, and also the maximum residual level. It's another guideline established by the European Medicine Agency in combination with the withdrawal time to ensure human welfare. And the second list on the bottom in brown, gray, whatever, has some compounds that have been submitted for registration to EMA, the European Medicine Agency. They have been assigned MRLs, but still awaiting full registration. Functional diets, this is a very significant addition, especially when we are targeting parasites against which there is no registered chemical compound. They have been used the last 2 decades against endo and ectoparasites. They are very easy to use, they do not harm the environment, and in most cases do not need registration. We have a wide commercial availability. They contain usually plant extras or a cocktail of alternative non-chemical compounds. The problem with their use is that when the parasitic infestation is progressed, their efficacy is very limited, and they require prolonged delivery through the diet that adds a significant cost to the diet, to the feed. Natural compounds, oxygen peroxidase is widely used in European and Mediterranean fish medicine. It's an environmental friendly compound in most cases. In some countries, European countries do not need registration. It's very effective against several monogenial pathogens and in most stages of sea lice. We have to be careful, especially during summer, because baths with oxygen peroxidase can be toxic to fish. Hyposalinity baths, they have a long history in aquaculture. They are very effective against protozoan parasites. There are limits in lab-based operation, although we will see later for some on-board treatments in salmon. The problem here is that although European fish species like sea bass and sea bream can tolerate even 0 salinities, pure marine fish like meager and amberjack are getting very stressed and usually are excluded from this kind of treatments. And the common dosing schedule of these baths is from 0 to 10 ppt for 1 hour. Now we can move to the mechanical advanced high-tech therapies. In the first case, we have the use of the laser apparatus for killing sea lice. This is a high-tech system that includes advanced software, camera, and a laser system. The salmon farmer uses place 2, 3 of these devices in each salmon cage. You can see that when sea lice are detected by the apparatus, the laser beam with green aims and kills the parasites without affecting the fish, of course. And the advantage here is that the use of this device is automated and operates in permanent basis. So in the second case, we have the famous thermolyzer. Again, we have music. Yes, thanks. So this is the famous salmonizer. Is specially constructed boat that can reach the big salmon cages and pump the fish into the boat. Fish are subject to specific conditions, and then they are returned with the pipes into the cage. It's based on the principle that salmon lice have little resistance to sudden high temperature changes as compared to salmon. So fish are subject to temperature changes from 30 to 34 degrees for half a minute. And this process kills most of the life stages. The problem here is that fish are getting very stressed due to this procedure, and they usually exhibiting secondary bacterial infection. And of course, this is a very expensive investment. So in the third case, we have the hydrolyzer. It's a similar, we don't have a video here. It's a similar boat to thermolyzer. The principle here is that lice do not tolerate fresh water as opposed to salmon. So fish with the same way are transferred to the boat. They are subject to freshwater treatment, sometimes in combination with hydrogen peroxidase, and then they are returned to the cages. The same side effects that we stated before are emerged. This is the use of cleaner fish, the biological war against sea lice. These two ugly fish, wrasse and lumpfish, are used sometimes alone or in combination in salmon cages. The proportion is one cleaner fish with 20 salmon. Something quite remarkable about the ability of lice to evolve and adapt this kind of new methods is the fact that lice have become much more transparent now, and the cleaner fish are struggling to detect lice and eat them. But still, the wrasse and lumpfish are now two very strong and separate from the salmon industries, and all the scientific disciplines like reproduction, nutrition, disease have been developed, especially by the Norwegians. So this is the third section of the talk. It focuses on the delivery of antiparasitic compounds. We will discuss only the main method used, the use of baths and oral. We have also the case of dip and flush that are used in raceways with salmonids. This is minor in Greece, so they will be not discussed. We have also the option of injection, which is used in valuable pet fish and broodstock. This will be excluded from the discussion. So what we did in this table, we have gathered all the pros and cons of each of the methods, and we try to make a fast comparison, starting from bats. We know that bats are very effective against ectoparasites, but when we target endoparasites, their efficacy is much more limited because the compound has to pass all the biological membranes of the fish to reach the target tissue. Of course, we know it's a very laborious application, especially in large cases, and it's very costly. This very short video showing a crane, on a platform, putting the formalin in the cages. This is a very complicated process. Usually take 3 to 4 hours in the farm, including the transfer of the platform to the cage, lifting of the net, placing the bag with the use of the crane. 1 hour is the duration. We have to wait for 1 hour, and then we have to remove the bag, the tarpaulin bag with the crane, and then unlift the net. So each farming site can run only 2, maximum 3 of baths every day. So it's a very strong limitation. It's also weather dependent. Of course, because we treat high water volumes, we use high quantities, and these may have some side effects to the environment, and they can become toxic to fish. On the other hand, dietary treatments are very easy to deliver in all types of aquaculture. Very important is we can simultaneously administer it to all cages, and this is very important for the parasitic cycle. The quantities, of course, compared to bass are much smaller, and the cost most of the times, and the side effects to the environment, of course. The problem with dietary treatments lie with the fact that when fish appetite has been compromised, we have problems with the delivery of the diet. And also most of these compounds have bitter taste. So we have to use some masking agents to camouflage, to improve the taste of the medicated diet. And because dietary treatments seem superior to baths in most aspects related to environment, the user, and the animal, the next couple slides will be devoted to some important aspects related to the proper timing of delivering the medicated diet and the preparation of the diet. So in order to understand that, we have to divide the evolution of the disease in different phases. The first and most important phase is the prodromic, where the infection is still low and the appetite of the fish is still in satisfactory levels. The prodromic phase followed by the acute one, where the infection is much higher and we have a lot of fish mortalities, and the appetite is now compromised. Then we have the chronic phase. The population is already decreased. We have some resistant survivors. The infection is lower and the appetite has become better. And lastly is the resolution phase. We have some natural survivors and the appetite is getting to the normal levels. So of course, the key phase here is the phase 1, because most of the fish are able to eat. So when they eat the medication, then can become protected by the treatment. And the second is the concept of metaphylactic treatments. This is a concept that is not well known or well understood. What we mean by that is that we must understand that treatments in aquaculture should be considered as metaphylactic and not prophylactic and therapeutic as in human and vet medicine. Here we need to understand that we target a very large population where disease is being developed. So we have some infect, some infect animals. And our target in metaphylaxis are not the affected fish that may not eat and eventually die, but those fish that are at some risk and can become infected. So to conclude, if we have to follow this concept, we need to, when we estimate the medicated diets, we should not consider the whole population, but only the part of the fish that will eat. This is not a very easy exercise because there is no quantitative data and it's based on our expertise and perhaps on some historical records. And also, initiation of the therapy should not be based when we are facing mortalities, but when we are observing some abnormality signs and followed by a proper diagnosis. And this is the last section of the presentation. It's a very significant subject. It's the interaction of treatments in the environment. This subject deserves hours or even days, but we don't have this luxury. And to make a long story short, what we did here is we have created a specific scenario with infection of Gilkes Subrim with spiricotil, the gill fluke. And we have the 3 main methods that we are using. So the first is the use of formalin bath. The second is the use of medicated diet with a chemical. And the third is the use of functional diet. So in formalin baths, we have to seal the net. The Standard dosing schedule is 200 ppm for 1 hour. We need repeat treatments because none of these methods can kill the parasitic eggs. In the second case, we are using the dosing schedule of praziquantel, 150 milligram fish per day for 3 days. Praziquantel is a promising compound widely used in Norway, in several Asian countries, and in Australia. We need also repeat treatments and functional diet. The functional compound should be included in 0.2 to 0.3% of the diet for a couple of months. So when the formalin bath is complete, all the chemical is released because we remove the bag, so all the chemical is going to the environment. In the case of the medicated diet, we care about the uneaten medicated pellets and the fish excreta, and we don't have any concern about the use of functional diets because it does not harm the environment. So what we did here is we have transferred information from the previous slide in a more specific scenario where we want to treat 100 tons of fish for 2 months during summer. So in the first line, in the formalin bath, we estimate that we need 4 therapies with a known dosing schedule. When we carry out baths, we calculate the water volume, not the fish biomass, and so we need 8,000 of cubic meters to be treated. The efficacy is always very high. We stress the problem with the use of baths, and at the end of this period, we'll have some tons of formalin released to the environment. In the second line, the medicated diet, the dosing schedule of praziquantel, we estimate 4 to 6 therapies to treat 100 tons of fish. Efficacy of praziquantel is also very high. The negative the concerns about the use of the dietary treatment have been stated previously. And at the end, we have some kilograms of the chemical release to the environment. And the third case, the use of functional diet, the efficacy is usually limited, especially when the infestations progress. Same problems with dietary treatments related to the fish appetite, and no problem about the environment. The use of antibiotic antimicrobial treatments has some serious concerns. We might have some environmental side effects that relate to the aquatic medicines. This include pollution of the water with some possible toxicity effects of flora and fauna, sediment pollution and contamination of non-targeted organisms, including edible scavenger, which can be accidentally consumed by humans. And of course, the development of antimicrobial resistance, which can be devastating for the efficacy of future treatments in the vicinity of these aquatic sites. And there's always a possibility of transfer of this resistance to other environments like livestock and human medicine. This is a huge topic and a public health issue that the humanity has to deal in the coming years. And although we compare the two main methods, and we saw some advantages and some disadvantages, the future strategy for confronting microbes in aquaculture do not rely on a single method, but rather on combination of methodologies and approaches known as integrated-based management, which is already used in salmon. This strategy aims to maximize efficacy with minimum chemical use without compromise the production of the site. And when we using methods and approaches that respect the environment, the consumer, the user, and the animal, we can claim that we can approach, we can reach the One Health concept, which is a modern concept, aiming to balance between these three important sectors: the environment, the consumer, and the animal. And before I close, this is, for those of you who want some additional reading, this is one of our latest works. It's a review article in a review journal. Actually, it's an open access environment, so you can easily reach it. There you can find more information about the antiparasitic approaches and strategies, always with emphasis in Mediterranean farming. Thank you for listening. Mm-hmm. Well, the Norwegian farmers are happy about that, so they still use it. I don't have data about, but the only thing that we can mention that one device is not enough for each gate, so they have to add more. So I guess it's still effective. They still use it. They do not complain for side effects to the fish, so this is important also. I have no clue.
Any other question, please?
Of course.
We also know that formalin is very toxic compound,
Mm-hmm.
and it's still used, but probably very soon it will be banned.
I know that. I know that.
So, how do you think that it will come up? I'm sure the last, you showed us the last slide that there's going to be a combination of various things.
Yeah.
Do you think that's going to be enough?
I think the next step, at least for Mediterranean and Greek, is in terms of antiparasitic treatment, is to find dietary treatment to be combined with formalin. So praziquantel is the #1 candidate. So there is a Greek company that has submitted a file to EMA 3 years ago. So we hope that pretty soon the commercial product will be in the market, and we will help to minimize the use of bats and formalin. Yeah.
Thank you very much.
Yes. Not suggested. I said the space limitation. We don't have too many. You know good about that. So it's, I don't know whether someone can move like the case.
Because the authorities in Greece ask from our studies, ask from us to include the family there.
Okay, that's good.
It's not possible in all these sites because there is no space or there are. So we need your support in some cases.
Okay, yeah.
Not now.
Yeah, super.
Thank you very much for your presentation.
Thank you.
If I may add, there are the OIs. So these are areas where many different companies can help the fish. So there are probably in there.
Glad to help.
For example, in a postcard,
Yeah, it's a nightmare.
you have these kind of areas.
Yeah. Good. Dismiss.
Yes.
They have a different perspective. Actually, all these limitations problems are one simple thing that locate how make aquaculture activity near the pole. The boys and all these planning, let's say, is something like 20 years. The thing is that now other further out, and what I see is that the whole sector is better, but actually the future by itself is one of the most, the sooner most, the higher, let's say, efficacy, it would be no succession and where to do the farming and the main problem, in my opinion, is the existence of quays and the limitation of quays. Some years, let's say 2010, they are not, they have up now, they have so when they have done some years, soon, let's say 5 years, the 45, we have 45 but now have these plants have something is something 8%. I agree with success.
It will never happen, that. Offshore in Greece.
But it's one component that should be discussed further. So, is there another question? Thank you very much.
Thank you.
Thank you very much for attending the session.
University of France. A master in oceanography in the University of Aix-Marseille, a PhD in oceanography at the University of Neuchâtel. Then continued at Florida State University of Tallahassee for a few years before joining HydroMediT. He is first and foremost an experimenter and has participated in or directed numerous disciplinary oceanographic courses. Very recently, so also. Throughout his career, he has explored various fields of marine science, from quantitative dynamics, self-sloping exchanges processes, to open ocean depth water formation, contributing to the understanding of complex interactions in the marine environment. His research focuses mainly on the Mediterranean, where he is heavily involved in both coastal and deep-ocean observation systems and with the new autonomous observation platforms. I just have to say that the talk that Xavier is going to give for us today is just one very small part of his activity overall, the different disciplines. So, Xavier, the floor is yours, and you can talk to us about whatever.
Thank you very much for this nice presentation. Right, as always, as I'm doing a presentation, I'm very scared. It's not easy, especially for a long presentation like this. So I could choose the subject I wanted to present. And in that case, okay, I went back to something I really liked to do 20 years ago. It was a project dealing with the impact of trawling, because I'm mostly involved in sediment dynamics. So trawling was part of one of the anthropogenic problem that could create a lot of turbidity. So I will go on and explain you that this interest on the bottom trawling on sediment date back from the early 90s. And when I was at sea, I used to spend part of the night during my watch on the bridge, looking at the ships on the radar. And I was struck at that time by the presence every night of many vessels working in parallel lines. And later, while I was analyzing the data from a mooring that I had to deploy on the continental shelf to study currents and sediment dynamics, I noticed that there was a systematic increase of turbidity in the last few meters above the bottom every night, with a periodicity of about 24 hours. And that was at that time that I became aware that there was maybe a potential impact of trawling activities. And I began to look at this effect. Of course, in the literature, I could find a lot of work already, but it was much later in the early 2000s that I was able to study the impact of bottom trawling in more detail through a European project. And there were some Greek colleagues participated because this project also took part in the Thermaikos Plateau close to here. Yeah. So bottom trawling is a fishing activity where a large net with heavy weights are dragged across the seafloor. Generally, it's done over muddy or sandy seabeds, and it just captures everything. And among the different fishing gears, bottom trawling is one of the top in terms of impact on the benthic habitats. And although numerous studies documented the direct impact of bottom trawlings on benthic habitats, the understanding on the global impact of this practice on sediment fluxes remained unclear until recently. And there is the first calculation by Oberle et al. In 2016 that suggests that bottom trawling induced resuspension amounts to about 22 gigatons every year. That's approximately the same amount of all the river input to the world continental shelves. So that's a huge amount of particulate matter that is resuspended into the coastal waters. So in this presentation, yeah, I will. Yeah, I know. Thank you. I will just do a brief reminder of the history of bottom trawling from its origin to the present day, because it's a long story. I will try to define the different topics addressed by the scientific literature on the impact of bottom trawling, and then I will give some illustration of the consequences of bottom trawling on sediment. So regarding the historical context, I choose this illustration on the evolution and change of the British trawlers fleet from the late 19th century to the early 21st centuries. But before looking at these pictures, I want to go back to the origin of trawling, and the first record of bottom trawling dates back to the 14th century in England, the 16th century in Netherlands, 17th century in Japan, and 18th century in France. So it's a long story. And in most of these cases, the reference are from petitions of people to decision makers who wanted to restrict or ban the use of these early trawl fisheries, because people at that time already knew that they had a big impact on the ecosystem. So bottom trawlers was initially used in coastal waters with just simple beam trawls until the late 18th century. Then we had the appearance and development of sailing trawlers throughout the 19th century. And the advent of steam-powered trawlers at the end of the 19th century that you can see on these pictures here. So it's a huge increase, enabled to explore new fishing grounds, use larger net, and remain at sea for extended period of time. Then after the Second World War, innovation contributed to the exponential growth of the fishing fleet. And you can see here the growth here. And despite the fact that for the British fleet, there was a decrease since then, it's not the case worldwide, because there are some calculations that indicate that the world fishing fleet just doubled between 1950 to until now, going from 1.7 to 3.7 billion vessels. So it's a huge activity worldwide. Okay, here I just illustrate the present day type of trawlers and trawling gears. So the trawlers appears in a variety of size, from the smallest one that are about 5 meters long to the largest one, about 100 meters, that are of course found in high seas. And the trawlers can work alone or by pairs. They can tow just one single net or several nets at the same time. They can operate down to 2,000-meter deep, meaning that they can cover mostly the whole shelf and most of the continental slope. And some configuration, like the stern trawling, are built to work in almost all weather conditions. Okay, here is a map that is done from a European project called BENTIS, and that work all over the European shelves. And here they measured the mean annual trawling intensity. And one measured is the swept area ratio. That's the sum of the area swept by bottom trawls every year, divided by the area of this region. And from this map, you can see that the Mediterranean and North Atlantic region, the North Sea especially, appears to have the highest trawling intensity, and that's true for the whole world. But there is a very sharp evolution of with time of the proportion of the shelf and slope area that is impacted by trawling. For example, here for the North Sea, the proportion went from 10% in the mid-19th century to 90% nowadays. That's a huge increase. Similarly, the recurrence of trawling has increased. And while only just few percent of the area was trawled at least one times a year, now it's more than half the surface that is trawled at least one times a year. And the study found that the trawling footprints is mostly localized and covers in most of the region studies less than 10% of these regions. So that means the trawling is the trawling impact is very localized, but it could be very intense. However, when we scaled the impact of trawling over the entire surface of continental shelves globally, the estimated bottom trawled area is about 1 million square kilometers, and that is at least 10 times larger than the surface of forests lost by deforestation. Because we often compare bottom trawling to clear cutting. So the surface is enormous. And the bottom trawling impacts are just multiples. And as I already said, they are compared to clear cutting. So dragging and heavy gears along the seabed can disturb the sediment and cause resuspension of particles into the water columns. This resuspension can increase turbidity and sedimentation rate. Besides, sediment play a crucial role in nutrient storage and transformations, and the disruption of sediment layers through trawlings can release nutrients into the water columns that potentially influence the ecosystem productivity. Bottom trawlings can also modify habitats by disrupting bioconstruction like corals or altering the seabed topography. For example, the increased turbidity and sedimentation can disrupt the feeding and reproduction of some species while favoring others, like shrimps. And finally, sediments serve as an important sinks for organic carbon that play a crucial role in the global carbon cycling and climate regulation. So trawling can release stored organic carbon into the water column, where it may be degraded and released as carbon dioxide. I will give some numbers later. And regarding the scientific literature, so I made some work with the World of Science database. So there is an emergence of fishery science around the mid-19th centuries as distinct disciplines that lead to the increased research on ecological impact of fishing activities, including trawling. But the impact of trawling on the environment has been examined in greater depth since the 80s. The number of studies began to increase in the 90s, and especially after 2000, with the advent of new technologies. So with these new technologies, that is acoustics, optics, or remote sensing, researchers and modeling, of course, researchers began to study the spatialist extent of the trawling impact, assess the habitat recovery rate, and explore the interaction between trawling and other environmental stresses. Then the number and diversity of paper published on this subject just continue to grow ever since. But the proportion of papers that are more specifically concerned with the impact of trawling on sediment, it's much lower, of the order of 10%. And that's the one I wanted to deal with. Now, concerning the landscape of research and this evolution over time, over the last decade, there was continuous works on the effect of trawling on the abundance and distribution of organisms, and that include, of course, the monitoring of changes in communities. The early 90s saw the first work using acoustic mapping to quantify the scars left by trawling on the seabed and their persistence. And from 2000 onwards, there were several complementary themes. The first one involved the setting up of scientific trawling experiment to determine more precisely the impact of trawls on the resuspension of sediment and associated dissolved elements, as well as on benthic habitats. And the second, sorry, it's a power problem. Okay, thank you. So the second theme use modeling to assess the regional impact of trawling on continental shelves. And it is noteworthy that these studies have benefited greatly from the information of movement of fishing boat derived from vessel monitoring systems, which has enabled a more accurate assessment of the region trawled. And I will show you an example of the improvement of the modeling with this new monitoring system. At the same time, there were the development of new instruments like sledge sediment profile imagery that permitted to assess the impact of trawling on the release of chemical elements and on the benthic fauna. Since 2010, studies have been carried out on the impact of trawling at greater depths, especially in submarine canyons and also some other continental slope. But among all these studies, there was a recurring objective. This was to assess and compare the effect of trawling on sediment resuspension and to compare it with the effect of storm-induced resuspension. In other words, it was the idea to compare the anthropogenic alteration of sediment with a major natural effect. And in a recent year, some other aspects of the impact of trawling have been addressed, and they are listed here, dealing with the noise disturbance, the impact of trawling on littering, on damage to shipwrecks, even the pandemics was assessed, and they also serve as an analog for deep sea mining. Okay, in this section, I would like to use a few examples from the literature and from my own work to illustrate the main disturbance on sediment dynamics. In that case, I will focus on otter trawls, whose impact on the sediment is generated both by the doors, the otter boards, and the ground gears that are indicated on the figures here. The ground gears is often equipped with chain or rollers to go over rocks. When it comes to trawling, you have sometimes to imagine that it can be very, very intense, as I already said, but here on the picture is very evident, and can be the results of an armada of trawlers working together, as on this picture in the China Sea. There are hundreds of trawlers working together. So you can imagine the impact on the bottom. And on the right figures, you can see the scars left on the sediment by otter doors that can persist for a long time. And when they are repeated, they can completely alter the given surface. And that's clearly seen on these sonar images. Okay, here are some figures on the sediment displacement associated to trawling. And sediment displacement caused by the ground gears, that's the lower part of the net, forms parallel tracks, while sediment displacements caused by the trawl doors create sediment piles. So you can see the difference between the two pictures. And the degree of perturbation from bottom trawling is obviously related to the weight of the gears. Nowadays, the doors are heavier and heavier, and so they can go deeper into the sediment, especially if it's muddy sediment. It also depends on the towing speed and the nature of the sediment. And on the two lower pictures that were taken before and after the passage of the trawl, and that's a sediment imagery profile, you can see the change of the thickness of the oxidized, that's the cleaner layer here, and that's the limits of the oxidized layer before and after the trawling, the passage of the trawl. And this is a good indicator of the penetration depths of the trawling gears. And the track left by outer doors is typically of the order of 10 centimeters. So that's what we observed and measured indirectly in many cases. Here I'm going to some effect on the seabed directly on the larger scale. And in this example, I will illustrate how repeated trawling can lead to the flattening of the seabed structure and the complete loss of the habitat complexity. And this is a very striking example that has been highlighted by Spanish colleagues from Barcelona. It is the La Fonera Canyon off the coast of Catalonia in northeast Spain. And it's home of a very, very important and very lucrative shrimp fishing industry. And on the bathymetric map on the left, show that this submarine is cut by, it deeply cuts the continental slope and goes down to 1700 meters quite rapidly. And that the steep wall are normally cut by numerous narrow channels called gullies. You can see them just everywhere along the floor. And the figures on the right, these are for the vessel monitoring system, VMS data. They show the intensity of the bottom trawlings around the shaft break and along the slope on the north and southern flank of the canyon, down to depths of about 800 meters. That's the white line on the graph. So it's a heavily trawled area. And they trawl every day, except holidays. And now they stop on some periods because they know that there is a strong impact. So they stop during the reproduction period of the shrimps. So the colleagues use high-resolution maps to assess the complexity of the seafloor. And on the map on the left, this is a map of the slope of the seabed, the inclination of the seabed. One can easily see in red all the steep parts of the canyons that are cut by very steep and narrow gullies. However, if you look clearly, you can see all the gullies here. That's all the red lines, many of them here. But if you look to the regularly trawled area, that's the area here and here, you can see that the irregularities observed elsewhere are more or less erased. And this smoothing by trawling of the seabed morphology is clearly visible on the bathymetric section that are represented here on the. And on each of these sections, we can see all the sections here are represented in 2D ways here. On each section, the blue part corresponds to the trawled area. And the black part correspond to the untrolled area. And you can see that all the existing channel in the trolled area, which should have amplitude probably up to 100 meters, have been completely smoothed. And this effect has been obtained within a few decades as it results from an industrial fishing activity that essentially started in the 70s. So in addition to this work, showing the flattening of the seabed by the trawling activities, these authors have shown that these trawling activities also generate daily turbidity currents that transport sedimentary material downward the base of the canyons every day at the same time. Now, regarding the resuspension of particles and the increase of turbidity in the water column by trawling, I choose an example based on my own experience. This was an experience that was done in 2002 in the Gulf of Lion. And in this experiment, we generate a turbid plume ourselves with using a bottom troll. And we also use optical and acoustic instruments towed by another ships that went over and within the plume to be able to map and analyze the composition of the plume. So on the left figures, you can see the experimental setup. And on the right, you can see the results seen by the EDCP. That's an acoustic device that gives a profile of turbidity, but also current within the water column. So the figure on the right illustrates the thickness, about 4 meters, and the width, about 100 meters of the plume generated by the troll. At the top is in terms of acoustic backscatter intensity. And if we convert it into a particulate concentration at the bottom. And if you look closely, within the plume, you can see these two increase here. That's the effect of the outer doors. Well, you should know that particulate concentration of several tens to 100 milligrams per liters are very, very significant for the marine environment. And you generally only encounter them in river plumes and during storm-related resuspension event. So this experiment also permitted to estimate the sediment fluxes generated by trawls that we could use later in the modeling experiment. But it also permitted to monitor the collapse of the plume. We just crossed the plume several times over time. And within a few hours, most of the particulate matter in the plume just settled back to the seabed, as most of the resuspended fine particles just aggregated and settled rapidly. However, there was still a small fraction of particles, the very fine particles that stay in suspension in the water column, and that is dispersed by the current. During the same experiment, we also did some chemical sampling. Here, we did some work on dissolved element, but here I just present results on the particulate element associated to the particles. And we observed a clear increase of their concentrations. In these three graphs, you have the concentration of suspended sediment, particulate nitrogen, and particulate organic carbon. Near the bottom, before the experiment, that's outside the plume in black, and inside the plume. In the same way as particulate material, dissolved elements such as nutrient or pollutant are released when the seabed are trawled. And these releases are likely to lead to a modification of the nutrient cycle and the carbon sequestration. And then I go back to a global estimate to see how important it could be when it deals to particulate organic carbon, there is a recent work that estimates that at the global scale, trawling is responsible to release into the atmosphere every year about double the annual emission from fuel combustion from the entire world fishing fleet. Just resuspension by trawl is releasing a lot of CO2 into the atmosphere. Now, that's the long-going work about what is the effect of trawling with respect to storms. There has been a huge improvement, a significant improvement of the estimate between the earliest work, that is one of these earliest work, and the most recent studies. And this is due in particular to the availability of the VMS data, which make possible to track fishing vessels and know exactly where and when they are trawling. And also to the improvement of numerical models that couples hydrodynamics and sediment dynamics. In the work of Churchill back in the mid-80s, this was the first attempt to estimate the impact of sediment resuspension by trawling on a regional scale and to compare it with the natural effect of wave and currents. Here, the mean concentration of sediment put into suspension by trawl have been estimated using very simple parameterization of the resuspension by trawl, as well as statistics of the fishing activities. And the mean concentration of sediment put into suspension by currents have also been computed using a resuspension model. And this first estimate indicated that during strong fishing activities, sediment resuspension by trawling can be a primary source of suspended sediment over the outer shelf, where storm-related bottom stresses are generally weak. So this was the surprise. Trawling is not just something that you can negligible. It's something that could be important in some cases. But this was just the first work. Then in 2002, or maybe later, with the experiment we did on the trawling the Gulf of Lion, with the PhD students, we decided to make our own estimate. So we carried out a numerical modeling on the impact over 1 year of the resuspension and off-shelf dispersion of sediment from the continental shelf of the Gulf of Lion by waves and currents on one hand, and by trawling on the other. And we also looked to the combined effect. So the Gulf of Lion is in the northwestern Mediterranean, and it's a fairly heavily trawled area. And also there is some very strong wind-induced storms. So at that time, in 2002, we didn't have access to any VMS data. So we had to estimate the distribution of the fishing effort from probability maps we had to construct based on the working habits of fishermen. And in these two maps, you can represent the probability of presence of the trawling fleet as a function of the wind intensity. When the wind is light, the fleet gives priority of working on the outer shelf. When the wind is strong, it works close to the coast. That was the easy way. So every day we changed the distribution of the fleet. And then we distributed randomly the vessels around these areas. I give you some time to look at the movie. That's an animated image on the right show every year the daily transport of particles within the water column. So if you look closely to the lower picture, you can see sometimes some dots. That's the trawlers. Okay, here you see them. And on the top, that's the resuspension turbidity or the suspended particulate matter concentration associated to resuspended by storms, by waves and current. So they are dispersed in the same way, but the location of the origin of the sediment is not the same. Because the more sandy sediments are close to the coast and the muddy sediment is on the outer shelf. So on the right, you have the daily resuspension rate due to the waves and current at the top, and here due to the trawling. So you can see that natural resuspension by waves and current mostly occur during short seasonal episodes and is concentrated on the inner shelf. Oops, sorry. In contrast, the trawling-induced resuspension occurs regularly throughout the year and is concentrated on the outer shelf. But if you look to the numbers on the left, you can see that on the shelf as a whole, the quantities resuspended by currents and waves are much, much greater by several orders of magnitudes than those resuspended by trawling. That's the idea. Storms are more efficient to resuspend sediment on a global scale. But now if you go in more details, you can see that the effect of trawling can sometimes be significant. And these two graphs here illustrate the distribution of resuspension fluxes as a function of depth following the shelf bathymetry and over two broad winter and summer seasons. You can see here the change of resuspension flux from, 40 meters down to 200 meters. Okay. During the summer, that should be the winter period here. And that's for the summer period. And that's for the trawl here. Of course, if you look to the data here, you will see a huge differences. But if I look in summertime to the effect of, or the non-effect of storms, you can see that trawling is almost as much or even higher. So in some occasion, like for the previous studies of Churchill, you can see that on the outer shelf, at some periods, trawling can be important, though in general, trawling is less important than resuspension by waves and current. And an important point is that despite its low impact on the resuspension flux, the trawling might contribute to a significant part, up to 20%, of the export of fine sediments from the shelf to the open sea. And I think this difference is probably linked to the area of the shelf that is mostly impacted by trawling, which is closer from the slope. So it's easier for the fine sediments to escape the shelf. And this was confirmed in another area from a very recent study in the Northeast Atlantic. It was located on the mid-shelf mud patch of the French Atlantic coast. And they made an experiment and some modeling experiment to compare the impact of trawling and compare it with the effect of waves and currents in a region dominated by tides. But in these studies, they were able to use VMS data. They had a lot of, and they could estimate in details the trawling activity. And the series on the right here, don't get about the same, it's over time, compares the resuspension of sediment in this area, that's the mid patch, medi patch, the resuspension of sediment by waves and currents, that's this line here, over time, with that induced by trawling, that's the one here. So you see that there is a clear seasonal patterns. It has been already seen in previous studies. And while the impact of waves and currents predominates in winter, the effect of trawling increase and can be dominant in summer. So we obtained the same results in different regions with different resolution and tools. Here, that's the bathymetry. Sorry, that's just the bathymetry. They were working on this area. And then in the subsequent modeling studies, these authors showed that there was a significant decrease up to 50% of the mud content in the trawling hotspots. So there is a winnowing of the fine sediments by the recurrent effect of trawlers. And this coarsening of the seabed has been already identified in other regions, like in a heavily trawled area in Alaska. So you can have a flattening of the seabed and a change of the composition of the seabed. And finally, as we observed in the Gulf of Lion, they estimated that the trawling could increase the natural export of fine sediments off the shelf by 30%. Thank you. So trawling is very efficient to enhance the shelf export. So I have finished my presentation. I go just for the conclusions. So the key point is that I did a very quick look on the subject that has rapidly evolved over the last decade, and even more recently with a few key papers that provide a global quantification of the effect of trawling. So the key point to remember is that well, trawling, of course, is was a coastal activity, has gradually spread to deep waters, especially within canyons, due to the change in the capacity of the trawlers. It produced a very strong impact on the seabed by disrupting the sediment and imprinting deep scars in the muddy bottom. And I'll show you that it could drastically change the integrity and the seascape. It causes a lot of resuspension and can disperse over the shelf, but also outside the shelf, very large quantity of padgilt and dissolved matters. Okay, we knew for a long time that trawling is not very good for the health of the environment. And so there is a new regulation that tends to limit the place where bottom trawling is allowed. And I've just recently heard the news that Greece will ban bottom trawling in the marine protected area by 2030. So there is an improvement in the regulation. And also there is something, because I was participating to some programs dealing with deep sea mining. And the experience gained by the study of impact of bottom trawling on different types of sediments may be applied to this ongoing debate. Thank you. Don't go.
Going particularly to the seascape, how can you stop trawling? How long would it take for that seascape to maybe return to some previous condition?
You mean the
Maybe never.
Never in some regions.
Ravines.
Yeah, because the scars, they can last for decades. In some other regions, because the sediment transport is very important, they can be erased. On muddy sediments, it can, or on sandy sediments, they won't last too much. But on muddy sediments, the scars will stay for a very long time. Yeah. That's okay. That's a good question, because to have a very good bathymetric maps with like 10 meters resolution, okay, they work with people from the University of Barcelona, with Miquel Canals, and no, that's a good question. I don't know. I think before this region has been trawled before we knew really about the bathymetry of this region.
Because I can see there the area down left, down right side, that have this type of area, drawing as part of the area. But
yeah. I think very. You're asking too many. Many I cannot answer. No, that's a lot of issues. I probably. Yeah. No, I've been working with them because we work in submarine canyons, but when they were a little bit north, looking at the transfer of particles, then the effect of some type of currents like dense shelf water cascading and storms. And we knew, well, some of these canyons, especially the one in Spain, are heavily trawled for a long time. So I don't know about the knowledge that were collected before this trawling started. The shrimp, yes. No. Oh yeah, because what we observe, because in the canyons, in this canyon, but also the canyons that are a little bit north, every winter we had dense water that is formed on the shelf and that escape the shelf and cascade down the canyons. And some years it's very, very strong. You can have currents up to 1 meter per second. And so all the population of shrimps just disappeared. It's just spotted elsewhere. And the fisheries just collapse. And the fishermen knew about that. They didn't know why it was happening. They knew that some years there were no more shrimps. And so now we make the link with these physical processes. And now they changed their fishing activities. They are not anymore fishing during winter time. They stop fishing during this period that is important for the shrimps. So there is an exchange of information. It's quite active, by the way. But all the questions you ask me, there are too much in there.
Some of your questions can imagine the answer.
Because I remember the first study on benthic habitats in these canyons, they date from the early 70s. And the fishermen already trawled this area. So only maybe the place that were not touched by trawling where you can find, or we could find some corals and stuff like this. But in this region, they just destroyed everything already at that time.
Thank you very much.
Strongest direct anthropogenic impact to the total environment. So there must be more questions.
I see a lot of students in chemical oceanography courses also, in addition the marine biochemistry. So yeah, they are the thoughts. I'm mentioning a situation of my postdoc, a publication of the ice category. And that shows the benthic meteoric layer during 2 seasons, and one of these 2 seasons has much more suspended matter close to the bottom, and is the period when trawling is permitted in Greece. Okay, so go back to your courses and see this slides.
Yep.
About this impact of trawling with my postdoc, also 2 papers by Caterina Combiado and the group of the Aristotle University Thessaloniki, very interesting modeling work, stochastic modeling on both on each net and the boat and the fleet. From the small scale to the large scale. It's very trying to I think you could the question.
It's a quick one because we can discuss later. But you know that we were working a lot in the present sea, so the place that I did some years ago, my PhD also started from the atmosphere, looking at sedimentation and then terrestrial organic matter. And I tried to do a mass balance of the different constituents of anthropogenic and biogenic carbon, let's say, compound. And in the end, in the deep sea, in all transits from the continental shelf, what is the continental shelf, deep sea, the accumulation rates of the different chemical species was something that, you know, there were 3 orders of magnitude in 2 seconds that there were 1 kilometer distance. So it seems that the perturbation is, as it is for the bacteria programs, but also for what it means for the different tracers. I mean, if somebody try to do some Oceanography a few years after us, I mean, everything is,
yeah.
Everything is, and also the thing of the CO2, I mean, we don't have, in this area, you have really serious degrees of carbon sequestration. But my question was because how deep the trawling happens, I mean, in the Western Mediterranean, because it seems that here in the Eastern Mediterranean you have really deep sea trawling.
I think that's the maximum here. So about 800, the maximum. But it's specifically designed for shrimps that lives next to the bottom within canyons. Because
there is nothing in there to fish. It's a big question why you try to go.
But there is a ban that now you cannot troll deeper than 2,000 meters or even less. 1,000. Yeah.
Yeah. The fate of this fine grains and material from the coastal areas that is suspended into storms is different than the fate of this material when it is suspended into petroleum. I mean, the suspension close to the coast has time to deposit it again before it goes to the open.
Yes.
When the other goes and different biochemical processes can take place. And my question is, have you put any sediment traps, sediment trap array in parallel to your studies?
No, we didn't know. No, I have to. I will think about it if I do this experiment again. Yeah. I would like to do the experiment again with new instrumentation. It would be nice.
I feel it's a question. Since there are many bottom trawlers with many who have already invested in this, are there any areas that are advantages for bottom trawling? Let's say, for example, areas that have been already done increase the biodiversity, but the suspension attracts species, but also cannot be done anymore from bottom trawling. So the idea behind the migration is that select some areas that would be relevant and specific for bottom trawling, and other areas that would be
okay. Yeah, I understand. That well, sometimes bottom trawling is favorable to some species. Bottom trawling is favorable to some species and not to others. That's I was just looking at the effect on sediment. I know it's so it has a huge effect on sediment, but I know that they are trying to improve to limit the bycatch of the trawling nets. They are trying to improve the design of the nets, but I'm not sure they are doing anything regarding the resuspension, because you are still scrapping the bottom. And during this experiment we did in 2002, we tried some demersal troll. That we just, the troll was just flying 1 meter above the bottom. And it had no impact, no resuspension at all. Only 2 weights were maybe touching the bottom sometimes, but we couldn't detect any significant resuspension. So, but I don't know about the catch because we didn't catch anything. Maybe some sardina, but nothing. No shrimps. No, it is for epibenthic or demersal species.
I played the devil's advocate. Let's say, okay, I mean, trolling is bad. Okay, we know that it's bad. But we saw that big amounts of particulate matter may be transported towards the bottom through the turbidity currents. Could we say that it could be one very indirect way to increase carbon flow towards the bottom, like an indirect carbon sequestration?
Or to the deep sea. To make a turbidity current, you should resuspend a lot of sediment, large amount of sediment. I don't know what will be the balance between what you release in terms of organic carbon. If it's degraded organic carbon, very low carbon, then the degradation would be small. We have to make the calculation, but I'm not sure it's a good way. Yeah. No, if it's fresh sequestrated, fresh carbon to the sediment, then if you release it, then it will be degraded and transform as CO2. But if it's already degraded carbon into the sediment, it won't change that much, I guess. So if you do that in regions where it's only petrogenic carbon, that's fine. It won't change. But it's already petrogenic carbon, so it's already trapped. I think in this experiment here, in the northeastern Atlantic, they wanted to tackle this problem because the people working in this experiment were from Ifremer, and they are also dealing with fisheries. In this experiment, yeah.
I'm not sure if they, they're so they are resistant.
each animal has several life stages. Maybe they have, all the screens, but you have 90 Celsius for the next slide.
Now this 30%, within part of chronic over there will be plenty of opportunities to answer this kind of question. So, I just a comment to do on turbidity. If you look to this bottle of water, it's very clear, but the concentration here, it's indicating it's about 200 milligrams per liter. When I say 50 milligrams per liters, when I resuspend sediment, the water that is, it was even clearer than that one. So when I say turbid, it's not turbid as we think it should be. It's still clear water, but it's turbid for the marine environment. It's clearer than this bottle of water.
So maybe it's under the tolerance of the species, but not recording significant cooling in the biological side.
Thank you very much. Thank you. Thank you. I saw you.
Κύριε Τσαμαδιά, μ' ακούτε?
Σας ακούμε, ακούτε?
Ναι, λοιπόν, παρουσιάζεται στις 4 η ώρα, έτσι, απομακρυσμένα.
Μάλιστα.
Λοιπόν, θα κάνετε share όλη την οθόνη σας, share screen δηλαδή. Έτσι.
Μάλιστα.
Λοιπόν,
Ναι, ναι.
θα σας αναγγείλει το Προεδρείο και θα ξεκινήσετε.
Ναι, θα είναι μετά τις 4, δεν θα είμαστε λίγο πιο νωρίς.
Ναι, όχι. 4 η ώρα θα σας αναγγείλει.
Εντάξει, σας ευχαριστώ.
Να είσαστε καλά.
Γεια σας.
Welcome to this session, thematic on environmental management and water literature. And I call to the floor for the first presentation, Professor Delgier, for the comparison of measurements of chlorophyll A concentration by different methods in its near goals. The first part of the presentation will be from Professor Delgier, the second part from Costa.
Good afternoon. Nice to be here with you on lovely island in this congress. Thank you for organizing the congress. I am Yücel Giyer. I am working at the 9 Eylül University Institute of Marine Science and Technology in İzmir. First of all, I will present, and after our PhD student, she will continue to present the presentation. In this talk, we will explore a comparison of measurements of chlorophyll A concentration using different methods in İzmir Gulf. It contains 5 sections. Introduction, study area, material method, result, conclusion. In this study, we investigated the dynamic chlorophyll A in the İzmir Gulf, employing various data collection methods to enhance our understanding of eutrophication process in this region. Eutrophication, a widespread environmental issue, poses significant challenges coastal ecosystem worldwide. Chlorophyll A is a key indicator for eutrophication. It plays a crucial role assessing water quality and ecosystem health. The aim of the study to determine the correlation between in situ measurement of chlorophyll A parameter using chemical methods. We consider CCAT methods, physical method, and satellite images. We will compare 3 methods in this same time. This is the Aegean Sea, and this is the İzmir, and we work in the İzmir Gulf. İzmir Gulf, situated along western coast of Turkey, is a dynamic marine environment characterized by diverse ecological habitats and significant anthropogenic influences. The Gulf serves as a vital economic and ecological resources, supporting fishery, aquaculture, tourism, maritime transportation. However, increasing nutrient inputs from agriculture runoff, industrial activities, and urbanization have raised concern about eutrophication and its impacts on water quality and its ecosystem. And 3 distinct chlorophyll A measurement methods were employed: in situ chemical and physical measurement, and Landsat 8 satellite imagery. Chemical in situ measurement, chlorophyll A were conducted using the Strickland and Pearson technique. Physical in situ measurement, we use it CCAT with this formula. We use this formula. And also, same time, we use it Landsat 8 satellite imagery was utilized to calculate concentration of chlorophyll A, was the experimental method using C2RCC algorithm. And after then, we use regression as a statistic method. In situ measurements were conducted at the 23 stations across Izmir Gulf to obtain data on chlorophyll concentration. This is the inner and outer part of the Izmir Gulf. This part of the Gulf is more prone to eutrophication, and the monitoring realized from 25 years in this area. And this is the this slide shows our research ship, chemical laboratory, the sampling prepared for chemical sampling. And here you can see physical in situ measurement, chlorophyll A concentration using CCAT. And here, this is the Landsat 8 satellite imagery was utilized to analyze spatial and temporal variation in chlorophyll A concentration in this study. And this is the Landsat 8 satellite image at the same date when we took the sampling in same date. And now,
And thank you, my advisor, and I will continue result. Analysis of the collected data revealed a strong correlation between in situ measurement, chemical analysis, CCAT measurements, and Landsat 8 imagery, indicating consistent findings. And the integration of remote sensing techniques with traditional monitoring methods enabled comprehensive assessments of chlorophyll A distribution and variability, highlighting hotspots of eutrophication and identifying potential sources of nutrient pollution within the Gulf. Temperature values between stations vary between 13 and 16 degrees centigrade degrees. Since it is winter, we can see that shallower areas indicate lower temperature. And this map shows the spatial distribution of temperature values measured by CCAT, and the ArcMap program was used to produce these maps. And salinity values in the Gulf vary between 37 and 40 per thousand. And the other parameter, suspended solids in the Gulf vary between 6 and 12 milligrams per liter. And chlorophyll A values vary between 0.5 and 34 micrograms per liter. And the chart on the right side of the slide shows a normal distribution of chlorophyll A concentration. At the bottom, descriptive statistics values in the table confirm this data. This slide shows the spatial distribution of chemical analysis in situ chlorophyll A and in situ CCAT and Landsat 8 results. If we look at these maps, there are a few differences about other measurements. At this stage, we conducted a statistical evaluation of the chlorophyll A parameter. Using regression analysis, we obtained coefficient of R squared equals 0.82 for CCAT and 0.96 for Landsat 8. In accordance with this evaluation, it can be observed that the methods are highly correlated. After this regression, if we look at these maps, it's possible to observe the results are similar. In summary, our study demonstrates the efficacy of integrating various data collection methods, such as in situ measurements and remote sensing, to investigate chlorophyll A dynamics and eutrophication process in coastal regions. And we observed strong correlation between in situ chlorophyll A and CCAT as well as Landsat 8 data, indicating the utility both of approaches. The satellite-based monitoring of chlorophyll A levels emerged as a promising tool for future eutrophication detection, especially considering its scalability over large areas. This capability could significantly support decision-making process for policymakers and resource managers. The insights gained from our findings offer valuable guidance for developing strategies to mitigate nutrient pollution and safeguard water quality, not only Izmir Gulf, but also in coastal areas worldwide. Moreover, the successful application of innovative technological methodologies underscores the importance of continued research endeavors in enhancing our comprehension of marine ecosystems and fostering sustainable management practices. In this presentation, we have shared your preliminary work with you. In our future studies, we plan to conduct a broader and more comprehensive study in the Gulf of Izmir and utilizing both 25 years of monitoring data and generating new and current data. And good afternoon, and thank you for your listening.
Satellite work is much easier. Yeah. I don't know, but how much easier is to plan and collect the data and have meaningful results in comparison with the work that usually we're doing.
Okay. Actually, really important in situ measurements. We correlated the satellite image also, but sometimes maybe you can listen the first section this day. Remote sensing imagery methodology, it's really important, and accuracy not better than in situ measurements, but large scale and really too cheaper and very accessible methods, and then generally use this methods and for technological, as a technological.
So we can use this method for the large area to have the main data to have an idea on what is happening on a big ecosystem like the Gulf, and then have in situ research only as a backup or in the sites that want to have more detailed information. Is it possible to work like this?
On this result, we will study another project. We have the institute data. And we try to log in this time corresponding to the same dates, same image in the past, and also we planning 3 years the future, comparing with in-situ data. And after we can see, this is the preliminary, we see regulation is okay, algorithm is working. This is the preliminary study for making a big project. And after, it's really, really easy to, because the cost, the monitoring is a very, very expensive cost. NER made this, Izmir made, which we make each season monitoring. And it is easy, but just preliminary study.
Thank you very much.
Thank you.
Hello, everybody. I'm happy to be here around you and being able to present to you the collaborative work of our team in Hellenic Center of Marine Sea Research, and more specifically, the Institute of Marine Biology, Biotechnology, and Aquaculture. The team is me, Melina Loulakaki and Dimitra Mavraki, and today I'm going to present to you citizen science platforms facilitate the rescue and standardization process for historical marine biodiversity data. To begin with, I'd like to say that this project was supported by two major projects. One of them is Horizon 2020 Future Mars, and the second one is EMPHITHEATER Biology, which focuses on data standardization and verification. It's a terminology that I'll explain in the next slides. First of all, I'd like to ask and answer a question. Why is the rescue of historical data important? As most of us know, we have plenty of notes or datasets that are lying dormant in our drawers, in our libraries, and we can never give access to the scientific community to them in order to be able to reuse it for their future projects or analysis. Like this, there are also online repositories such as Biodiversity Heritage Library with multiple of historical papers that include information, important information, but if we do not extract them and transform them into a more standardized and acceptable format, we cannot find them and use them easily. The primary aim of this study was to find information from these historical scientific papers that we are unable to use OCR softwares in order to extract their data and convert them. So we selected tables from historical datasets. And then we wanted to use citizen science platforms, and specifically the Zooniverse platform, in order to transcribe and standardize their information. We wanted to conclude in a FAIR format of this data, and FAIR is the first letter of findable, accessible, interoperable, and reusable. The workflow was pretty simple. First of all, we had to select relevant papers for our work, and then to find a specific online platform that will host our project. This was Zooniverse because it's a user-friendly environment and easily accessible for multiple users. The idea was to provide guidelines and a step-by-step tutorial in order to explain to the volunteers how to approach this subject and help them in order to help us in for our purpose. Also, we disseminated this project in a workshop in Lecce last November that had success, considering that during this period and the next weeks, we had a peak at the engagement of the volunteers. During the workshop, we trained some early career scientists and some students in order to help us with this process. And eventually, we extracted the data from Zooniverse. We applied a quality control on them and on some original data. I'll explain in a while. And then we included their metadata under FAIR principles and uploaded them on Medobis. These two datasets were from 1895 and 1896. The first one was from an expedition around the coast of Tunisia and Algeria, and the second one, it was one from Polar's expedition, which challenged the Azoic belief with abyssal mollusk findings of the era and expanded the knowledge of the Mediterranean mollusks distribution in the area. We chose to work with citizen science because we want to engage the public in the process of data standardization and verification. Also, it gives you the opportunity to expand your project in a way that you can put a higher volume of data. and also enhances the public awareness, and we simultaneously educate them. The Zooniverse, as I mentioned before, is a user-friendly platform for both the volunteers and the project builders. So we selected this one. Also, it has various different approaches in order to build your project, and also ensures very specific data extraction format that is easily convertible into an XLS file with a specific script. Medobis is the central hub for regional marine biodiversity data that is hosted in Hellenic Center for Marine Science, and it feeds systematically the OBIS with data from Mediterranean Sea, and also supports the fair data principles. In total, we had 44 volunteers that worked in 151 completed subjects. Each subject is a row of the tables that we found in the historical paper. And for every subject, each volunteer wanted around approximately 6 minutes to complete. For the whole project, we needed 76 days from day zero until the day that all the subjects were transcribed at least 3 times. The outcomes was in total 273 distinct species of mollusca that were identified a century ago and more. And yes, now that we did all this process, these data are accessible via Medobis platform. Simultaneously, we enriched with some historical species names the worms database, because in these historical papers, we found names that were not present in worms. It's not new species, it's synonyms or some species names that had typos, but we had to enrich also, to contact the editorial team of worms to enrich their database because they are present in published literature. And of course, now these data adhere to FAIR principles, and you can find them easily, you can use them and reuse them, or apply a meta-analysis on them. Finally, I'd like to mention the importance of the quality control. First of all, I'd like to say that there were typos, so this is important to correct, especially if you have species names. But most importantly, we found some mistakes in the original paper, which had to do with the coordinates. As you can see in the first image, before the quality control, the coordinates from the first historical paper about the expedition around Tunisia and Algeria coast had coordinates that landed on that pointed the land, and we had to find the names of the locations and use a Nobis tool to create a polygon around the area mentioned. So we provided the corrected coordinates with some uncertainty in the final data. For the future, this project is an approach that engages citizen scientists in the data verification process, so it can be modified for your needs or for everybody's needs, and for this purpose. And also, it's a foundation for a good foundation if we want, or if you want to include much more papers in this workflow. It's easy. You just have, or we just have to convert the tables from digitized literature into subject images in order to be easier for the volunteers to complete their tasks. I'd like to acknowledge the contribution of Future Mars and IMODNet to the project, and thank you all for your attention. Thank you very much.
Interesting work. All data needs to be updated. Do we have any question for the presenter? Thank you. Are you
planning to use this tool to other papers or to other disciplines?
We have started this initiative. We use our work in HMR of the team is to enrich the Medobis with new data, and of course, historical data sets are multiple. So yes, we are planning to enrich it even more. Also, thanks for doctor, but I'm a doctor to be, so in the process. Thank you.
Hopefully, to the next Congress, you will be full doctor, not in and that you can see about how this tool is working. Thank you.
Thank you very much.
This one? Yes. From Spinos Dimitriadis, Trioti, Maidanu, Samarias, Negres, and Tubas. Mr. Samarias will be representing author, and the work is on the preliminary study of the abundance of 3 species of jellyfish in northern Kiparisiakos Gulf and management implications.
Mr. Tsamadias, you can start.
Okay, can you hear me? Do you hear me? Okay. Thank you, Chair. It's been a pleasure, at least hearing you again. We've been working together for many years. I'm going to present the results of a preliminary study concerning jellyfish in southwestern Greece. I would like to share my screen. Okay. Can you see the presentation?
Yes.
Okay, thank you very much. The title, as Dr. Hadjiepstathiou just said, it's about the preliminary study of the abundance of 3 species of jellyfish in northern Kiparisiakos Gulf and management implications. Kiparisiakos Gulf is in southwestern...
Mr. Tsamadias.
Yes.
Full screen, please.
I need to do something. Full screen. Share. New share.
Perfect.
Okay. Thank you very much. Okay. Blooms of jellyfish are increasingly common nowadays worldwide, including the Mediterranean area. The increase in the jellyfish populations is likely to have ecological impacts, such as altering the structure and dynamics of the marine food web. This could be attributed to increased predation on prey, on development and reproduction of marine organisms. The increased population of jellyfish could also indirectly reduce natural fish stocks, even by competing with planktivorous fish and their larvae. These days, the jellyfish blooms may affect human activities such as tourism, fishing, and coastal and industrial facilities, including water pipes and similar facilities, and even aquaculture. In this study, we saw the abundance of 3 species: the jellyfish, Rhizostoma pulmo, which is that is the largest species in the Mediterranean, also known as giant blue jellyfish. The second species was Cotyloryza tuberculata, and the third species was, if you permit me, the notorious Pelagia noctiluca, due to severity of its stings. These are in situ pictures. We are familiar with this, I guess. This is this, and this is, we can say, the study area. This area is rather narrow, and the substrate is quite softy. We may see the Catacolo port and the Alphios estuaries. In the same, we chose to show in the same slide the results also of the abundance of 3 species. We may see that there is Rhizostoma pulmo is located mainly in the shallow area, more in greater depths. It's the Pelagia noctiluca, and in greater depths, it's the Cotyloryza tuberculata. We see just a difference concerning Cotyloryza tuberculata, which is near the shoreline in the cap of Catacolo, where the substrate it's not so softy, but there are rocks over there. It was more an empirical study, and we monitored the surface, not the water column. We had a questionnaire, and we tried to get some answers from local residents, professional fishermen, tourists, and people that were in the area. We tried to detect if there was a variation in abundance of 3 species between the decade 2009 to 2019, and in which year, 2019, 2020, or 2021, were the fewest jellyfish population. We also saw that jellyfish were not in the area during 2020. And in the question, what species was dominant in the area, the answer was by 95% Rhizostoma pulmo. Of course, the respondents replied that jellyfish appear in the summer. In the next slide, we may see the monthly variation of salinity and temperature in relation to jellyfish appearance in 2023. We see the trend line of salinity and the trend line of temperature. we see in this slide, in this graph, we see that all three species are present in the area, at least in the surface of the water column, during summer from June to September, with the exception that Pelagia noctiluca is also present during February. Finally, what we found was that regarding the systematic recording of appearance and abundance of jellyfish, we need to develop relevant methodologies and work protocols. Drones, unmanned aerial vehicles, could contribute to this direction to save some resources. It would be quite fruitful to identify the areas of hard substrate from which jellyfish originate during the planula stage. The estimation of the population and the distribution in time should be examined in relation to relevant environmental parameters such as water circulation, temperature, salinity, currents, and secondary productivity. Sometimes in near future, we should be able to quantify the impacts of jellyfish outbreaks, first on fisheries and then on tourism of each area that is affected by a jellyfish bloom. Among the potential management actions to address the population outbreaks could be initially measures regarding to innovative fishing methods such as small selective nets, and we could use that biomass could be used. The second, which was done in Greece, which has been implemented in Greece since 2017, was to place protective nets in coastal areas for the safe swimming of bathers, especially regarding to Pelagia noctiluca. Practical applications to this potential biomass removal could be soil improvement, aquaculture, and pharmacology. Last but not least is that a creation of an observatory for the study of jellyfish might prove to be very important. Jellyfish blooms, a topic that is so far little studied, we believe that will increasingly preoccupy first the scientific community, as well the coastal local communities of our country, which is heavily dependent on tourism and fishery. This work had received no funding, and I would really like to thank you for your attention.
Yes, for this presentation, this interesting and difficult issue. Do we have any questions from the audience? Thank you for your presentation, and hopefully we'll have further results in one of our next congresses.
That's our ambition, sir. That's our ambition. Thank you. Thank you very much.
Into the next presentation from environmental impacts and challenges to your sustainability in mining and the global concerns from Bernard and Nicolau.
Hello, everyone. Thank you for being here. Today, I will present you the work I did with Mrs. Nicolaou about deep sea mining and its sustainability. So first, we know that over the past decade, there is an increase in the need in metals, and the land-based resources are very limited. So that's why since the 60s, sea mining is considered. During a lot of time, the we were limited in depth because we didn't have the technology to drill deep enough, but now we can drill in areas deeper than 200 meters, which is the deep sea habitat. So the deep sea habitat is one of the most extensive habitat on Earth. It is characterized by the very low temperature, very high pressure, and low light intensity. Most of the species living there are very adapted to these properties. And they also play a major role in the sequestration of atmospheric carbon absorbed by the top layers of the ocean. Today, the limit in deep sea mining is mostly due to the lack of knowledge we have about the habitat and the resilience of the species living there. So the seabed mining industry is mainly focused on three resources. The first one is the manganese or polymetallic nodules. They can be found on the abyssal plains, and we just need to harvest them in order to collect them. Then we have the seafloor massive sulfides. They can be found in hydrothermal vents, and we need to drill in order to extract them. And finally, we have the cobalt-rich ferromanganese crust, which can be found near seamounts, and same, we need to drill in order to extract them. Today, the main focus of the deep sea mining industry is on hydrothermal vents because we have the technology to drill. It's very similar to the one used in oil drilling. And also we suppose that the species living there have a very short time of regeneration, so they can adapt themselves faster. The main problem are for the cobalt-rich crust mining because it's a technical challenge, and also seamounts are considered as an important source of nutrients for the deep sea habitat and ecosystem. Deep sea mining operation takes place in 5 steps. The first one is finding where are the resources and obtaining a license. Then they do in situ measurements to know the quantity and the quality of the deposit. Then they can assess the viability of the project. And finally, they can do a pilot mining operation, which is 10 times smaller than the final scale mining operation. This step is very useful to get some in situ data about the disturbances caused in the deep sea habitat. And finally, they can do a full-scale mining operation. Today, the International Seabed Authority, which is in charge of the sustainability of the exploitation of the deep sea, has only issued 30 exploration contracts. So there is no full-scale deep sea mining happening right now, only pilot mining operations, so small-scale mining. And we don't know a lot about the environmental impact of deep sea mining because there is no full-scale operation. But with Mrs. Nicolaou, we had looked to the data for the land-based mining near the seashore and also shallow water mining and tried to interpret them for deep sea mining. So the first concern is about sediment plumes. These are the tailings due to the drilling and also due to the washing of the ores at the surface of the sea. The area impacted by sediment plumes depend on the size of the particles and also the turbulency of the area. We know for sure that sediment plumes will increase the turbidity of the water, so it will impact the bioluminescent organism. It can also cause the clogging and the smothering of the tissues of filter-feeding organisms. It also buries the benthic organisms. And finally, we can find some paper talking about a lower oxygen concentration due to the organic matter contained in the plumes. The second concern is about the toxicity of the metals released in the environment by deep sea mining. Their toxicity depends on the temperature, the pressure, and the phase of the metal. We don't have any data for deep sea environment, but we know that low temperature normally decreases the toxicity of the metal, so that's a good news. About the pressure, it depends on the metal. High pressure can increase, decrease, or does not affect the toxicity of metals. And finally, the phase, we know that when the metal is dissolved, it's easier for it to get inside the organisms, but even if there are particles, organism can ingest them, and then the metal can accumulate in the organisms, and it can cause greater problems at higher levels of the trophic chain. We know that some deep sea organisms can detect pollution and they can adapt their behavior. For example, they can close valves or opercula, but these behaviors are only temporal behaviors. Then we have some concern about the noise. We know that there is no anthropic noise in the deep sea environment, but a lot of species use the noise for hunting, communication, and navigation. In the deep sea, as the water is very dense and the noise due to deep sea mining are mainly low frequency noise, it can go with great velocities and disperse over great areas. So we expect that the hunting, the communication, and the navigation of species will be disturbed by anthropogenic noise, but also anthropogenic noise increase the stress level, and which have consequences for the metabolisms of the organisms. Then there is some light pollution. There is no sunlight or anthropogenic lights in the deep sea, but we can find some light due to bioluminescent organisms and also thermal radiation, which are near infrared radiation. Anthropogenic lights could attract some species and also disturb the diel vertical migration of plankton and cause damages to the retinas of the species that are only used to near-infrared radiation. Then there are some concerns about the temperature. We know that the temperature in the deep sea environment is very low, around 2 degrees or 4 degrees, and very stable. There is no seasonal variation in the deep sea. But the drilling machine releases heat in the environment and also the water waste, which is 11 degrees higher than the water at the bottom of the sea. Most of the species living in the deep sea habitat are stenothermic species, so they can only survive in very narrow ranges of temperature. We expect that a new temperature distribution will have a new species distributions and new interaction between species. So maybe some will become extinct and some will proliferate. We should also note that a higher temperature increases the toxicity of the metals. So both are linked. Here we have some more general impacts in the biocenosis. We know that if we change the environment, they will have to find adaptive response, and implementing adaptive response require a change in the energy repartition, and the species will have diminished fitness to the environment. We can also talk about the transport of non-indigenous species by the vessels, which again, a new species repartition, new interaction, and maybe the extinction of endemic species. Their plumes cause the death of benthic organisms by the burials of the organisms. And with the compaction of sediments, it decreases the primary production of the seafloor. The pelagic species are also impacted because of the cables between the vessels at the surface and the drilling machine. It can entangle big animals. And we should note that the sessile and slow-moving fauna will be able to escape most of the pollution. However, the benthic fauna will have to adapt. Here we can find a map of the deposits that can be interesting, and we see there are some in the Mediterranean Sea. Finally, we have some sustainability remarks from the International Seabed Authority. So they have implemented preservation reference zone, which are controlled areas with no mining activities. And there are also implement impact reference zone where take place 30 pilot mining operations to know more about the environmental impact of deep sea mining. We can also improve the design of the machinery used because it can significantly decrease the plumes created by the drilling and also limit the sediment compaction. Finally, we can stop discharging the waste into the sea but take it back to the land, do some detoxification protocols before releasing into the sea, but it requires a lot of maintenance organization. And we can also adapt the working hours and the signal of the wavelength used to reduce the light and the noise pollution. Here you can find the references we used. And thank you for your attention. De rien. De rien. No,
Is anyone from the audience have a question? I saw during the presentation with the problem that you are causing identifying the causing problem is also the presence of light.
Why is the light?
Yes, because if we have a deep sea mining, probably there's no light.
There is light from, because they use rovers to eliminate the mining path, to see what is happening under the sea. And in a lot of papers, they say that they have to use it. They cannot remove the lights. They can just like lower the intensity of the light, but they cannot remove the light.
The rover gives light not only during the installation, but during the maintenance period.
During the drilling, yeah, during the drilling. But the pollution due to the lights will only happen during the drilling operation. When the drilling is finished, they will not have any repercussion, not like the temperature that will take time. Yeah. Benthic organism, the main problem is that we have plumes in the environment and then they will go back to the seafloor and it will bury them. They will be buried. But maybe there is some vibration too, but it's not studied in the paper before.
Thank you very much. Consequence of Malia. The product analyzer are investigating species and the pathway regards the protection of European biodiversity and from a destructive creatures to a source of wealth. It's a big deal. Papadaki, Karachlev, Triadis, Kurakis, Kivari, Maguire, Mancinelli.
Yes. Hello, my name is Sofia Papadaki. I'm coming from Athens, from Prince's spin-off. We are one of the first spin-off of National Technical University of Athens of the Department of Chemical Engineering. And this is one of the first projects that we run, and we have the role of dissemination and communication manager. Okay. So I would like to give you an overview about our project, Valias project. Our main objective is to manage marine invasive alien species and transform them into a valuable resource for the economy. Our main goals is to protect the biodiversity of the European seas, to create new market opportunities for food, aqua feed, and cosmetics, industry by using this undervalorized resource. Our project, it was funded under the topic of Marie Curie RISE actions, that is actions dealing with staff exchange. All the project is implemented through the exchange between young researchers, between companies and universities. So just a few facts about our project. We are 8 partners from 5 countries. We try to cover all the areas of invasive species. That's why we have Ireland, Italy, Cyprus, Greece, and also Bulgaria in our consortium. In total, we are going to implement more than 300 months of secondment. The duration of the project is 4 years, and the budget is more or less 1.5 million. You can see many well-known and prestigious organizations in the field of marine sciences like HCMR, which is also our coordinator, Bantry Marine Research Institute from Ireland, University del Salento from Italy, and also we have, as you can see, TACASC, which is an Irish institute about agri-food sector for the food product development. Nuevo, a producer of fish feed, Physiopharma, a producer of cosmetics, the European University of Cyprus, the Department of Medicine, that they are going to implement all the toxicity and safety tests in our products, and Prinsus, that we run the horizontal work package of techno-economic analysis and environmental assessment, and also the dissemination action. Our aim through the collaboration of our consortium is to promote cross-sector collaboration within academia and industry, and find practical solutions for the problem of the population management of the invasive alien species. We will try to enrich the interdisciplinarity between the research areas, and also to strengthen the exchange of knowledge. Our main research objectives is to valorize these new resources through finding sustainable methods to utilize the invasive alien species as a feedstock for bioactive compounds recovery, to find economic benefits by establishing new types of fisheries and products to benefit the professional fishers and the related industries. It is a win-win solution for both fishermen and also the environment. To enhance the productivity of aquaculture, food, and cosmetic sector, and through the valorization of invasive alien species feedstock to create stable and safe new product value chains, and address the ecological and economic impacts of their presence in in the Mediterranean basin mainly. The main drivers for this project were to facilitate the circular bioeconomy practice, and to be in alignment with the European initiatives, to mitigate the negative ecological impacts through the efficient control of the population and the expansion of these species, and to promote the collaboration and interdisciplinarity in an area that maybe somebody cannot expect that expertise like food technology or cosmetic technology or chemical engineering can be merged with marine science and research. So the greatest aim is to find and establish valorization pathways about these species, to drive economic growth, especially for the local coastal communities, and of course to empower marine biodiversity conservation. The critical issues that we would like to address through this project is to enhance the comprehension of species biological requirements that is asked from the EU Directive 1143 of 2014, to achieve an efficient invasive species management by developing strategies that can prevent the spread of NIS and ES and invasive alien species in the Mediterranean basin, to develop innovative and eco-friendly methods for their valorization, to create business models and techno-economic feasibility studies for these new value chains, and also the most important is to come in accordance with the regulatory compliance of EU regarding the products and the species. Our ecosystem is supported by the interested parties, which is the fishing community, the academia, the researchers, the cosmetic, feed and food industry, and at the end, of course, the consumers. And our second stage is the added value chain, that is the alien species that are going to be targeted for fishing, the recovery of valuable compounds, the formulation of stable and safe ingredients, and at the end, the development of new products. The added value that we create in each of these steps, in the first case regarding the fishermen, is the new source of income, the prevention of fishing stocks, the new jobs creation, and the biodiversity conservation. The benefits and the added value from the academia and the recovery of bioactive compounds comes from the valorization of unexploited resources, the new know-how on stable and safe ingredient production, and the sustainable processing. Regarding the industry, the added value deals with the new ingredients that are functional and safe, new solution towards resources scarcity, and the development of new innovative products. Regarding the consumer, the human health will be promoted, the food security will be enhanced, the environmental preservation also, as well as the sustainable product value chain. The steps for the implementation of Valia's project is actually 5. The first deals with the marine invasive alien species selection, mapping, and also the pathways of their expansion. Some of the selected species that we are going to study is Asparagopsis armata, Crepidula fornicata, Lagocephalus scleratus, Siganus, Fistularia commercioni, Diadema sedosan. And we are going to proceed to the full characterization of these species. The second step is going to be the optimization of extraction process to recover the valuable compounds. The third step deals with the formulation of the safe and stable ingredients through the encapsulation of the bioactive compounds, the development of final food, fish feed and cosmetic products, and at the end, the overall sustainability assessment of these new value chains. Our great innovation is the development of new valorization pathways for the invasive alien species, the sustainable ingredients development, the bioactivity enhancement through encapsulation, the product development in accordance with the European legislation limitation, and also the promotion of encapsulation techniques for the innovative production of ingredients with stability and bioavailability. The key results is going to be the process to optimize the selection of marine invasive alien species based on undoubtable criteria like the invasion status, the habitats, the crucial that crucially enhance the product development, the innovative bioactive compound extraction, and also the market-driven products development. The product development, as we said, it will be based in innovative formulation that incorporate bioactive agents in a stable formulation that ensures safe and high quality products. All the products are market-driven. We have indicated the most important for the current market products, and the encapsulation for control, release, and delivery of all these functional compounds derived from the marine resources. The market and economic impact of our project deals with creating new fisheries. So we create a new fishing status for the fishermen, the economic return for the fishers through the revalorization of invasive alien species feedstocks that leads to an efficient economic return and development of the local coastal communities. And also the commercialization of our final products through the conduction of a thorough market research that enables the identification of any potential markets, even niche markets. The sustainability and environmental impact, of course, we are going to assess the sustainability of all this endeavor by assessing environmental impact with life cycle analysis. We will try to maximize the eco-efficiency for sustainability, which means the profit, what we can earn from this new strategy, and also their impact in environmental terms, and economic output optimization through life cycle cost analysis. So our main outputs and achievement is new fishery strategies, value-added products, efficient ecosystem management, economic and social benefits, especially for the local coastal communities, and of course, the promotion of sustainability through a circular economy model. At the end, the future directions is to advance the research towards this very crucial topic, to expand the scalability of our endeavor at the end in order to create at the end of the day a coherent new value chain with potential to be scalable and industrialized, and also ensure the long-term sustainability. This is from my side. Thank you very much. Here is the contact information for our project. We can scan our QR code in order to have access in all social media and follow us. And we'll be more than glad to come in contact with you whenever you wish. So. It is very important to fight, and that's we are going to try. We have make a first attempt in a Greek-funded national project where we tried to develop, in collaboration with HCMR, new fishing tools that will help the fishermen to capture the invasive species, because the majority of them, it is through scuba diving and picking locally. So our first aim is to try to develop tools in order this fishing strategy to be efficient at the end of the day. And, you know, this project, you know, open a great, very big chapter in the valorization of this species. And now that you said that you came from Turkey, in the recent ITEREG call, we make an attempt also with METU University to try to find some solutions. We submit a proposal about the medicinal value and medicinal products from local Turkish invasive species. It is mandatory to do something.
Results of the project. We said that we are very get this as the preliminary the first presentation of the project. Because of all as I Ichthyology, it is in the collaboration project is a new one. It will be very interesting for the participants to see how this works. It will foster the collaboration with the project partners and with the society. Significant part of this congress is also the educational part for the young students undergraduate program to see how the project is structured, to see how the work is must be done for a project to be funded and implemented. So it's thought that this will be very useful for the participants. That's why that we have a discussion and yes, okay, we can accept project even if very start
early stage, yes. You know, the most important is also the topic of the call. These Marie Curie actions that they give a great opportunity to students. Actually, you know, through this project, a lot of new PhD theses started, or we started with some students that they are at the last year of their studies, and then through the implementation of the project, they proceed to a PhD. So it is, and they have the opportunity also to work in a real industrial environment. They give them the opportunity to get out from the, how can I say, a restricted academic area and face the real world problems and industrial specification and demands. So thank you very much. Thank you. Thank you.
It's a very big team. Yeah. But maybe the work from the Department of Marine Sciences, students and teachers.
It's one of the partners of the consortium. Good afternoon, everyone. My name is Stamatis Petalas, and my background is actually in physical oceanography. So I will be presenting you today results from a project which is quite different from what I'm used to tackle. But nevertheless, it's a very interesting project called My Blue Home, which promotes ocean literacy to primary school children through two innovative tools, let's say, a digital game and an ocean museum. So if we take a look at the present landscape in education in Europe as well as in Greece especially, the environmental related subjects, although they exist, they fail to include the role of the ocean in the climate system and especially the theoretical background between on how the ocean works in general, so the physical, chemical, biological aspects of oceanography, subjects like marine biodiversity, the ocean's role in climate change and sustainable practices, as well as the role of the ocean on human societies is not thoroughly covered, let's say. My Blue Home project is an Erasmus Plus project which targets primary school students aged between 6 and 10 years old. The focus is on promoting ocean literacy in the classroom by encouraging the implementation of sustainability practices. The consortium is made up of 6 partners. The University of the Aegean is the academic expert, let's say, in the consortium, and it is responsible for the management aspect as well as the scientific subject, let's say. Advances is a company from Portugal, which is a research and development company for education. Boon, another company from Portugal as well, is responsible for the design and the illustration of the project. The Arad County School Inspectorate from Romania is the institution responsible for the directorates in education. And 2 primary school institutions, one in Italy, the Istituto Comprensivo Giovanni Paolo II, and the primary school of Varia, are the institutions which also play the role of testing grounds for our project results. The first step towards our tool development is the selection of a pedagogical framework for the project. And then we have 2 main tools and deliverables or results. One is a digital game, which gives a gamified experience to the students who can play it in the classroom for under the supervision of teachers. And the other tool is an ocean museum, again, which is supposed to be built within the classroom and gives a hands-on action-based experience on the subjects that regard the ocean role in the climate system. We also developed some tools for testing our results, which are basically quizzes and questionnaires. And these are supposed to engage students and test their learning in the end of the day. The pedagogical framework was built around the UN's Goal 14, Life Below Water framework. We try to tackle theoretical understanding of how the oceans work, the interactions with other parts of the Earth system, the impact of human activities on the ocean. We tried with this pedagogical framework to foster environmentally friendly behaviors and enhance critical thinking, problem-solving skills, teamwork, and in the end, spread awareness about ocean sustainability issues to the wider community. Going to the first result, which is the first tool, which is the digital game. You can see a map on the figure, which is the main screen of the game. It is a point-and-click adventure game where the player can interact with objects and talk with characters that are within the game. In each place where the character goes, you enter a new environment, And you use help from the non-player characters and try to gather objects from the environment to finish the missions. There are 4 missions in total, with advancing complexity level. Usually, in the beginning, there is an alert about a problem that exists somewhere in the island, and the player needs to solve the problem and restore the system to its initial state. In the first mission of the game, the importance of the ocean for recreation and transport is highlighted. The game begins with an oil spill alert that closes a local beach, and then the students or the players find out that the ocean is very important for recreation, tourism, and transport. They find out that shipping operations can produce pollution, and that seaports are very important infrastructures, but however, accidents can happen. At the end, the students realize the importance of having a coherent risk management plan, and they find the source of pollution and help reopen the closed beach. In the second mission of the game, the importance of the ocean as a source of food and resources is highlighted. Again, there is an alert for low fish stock and a reduction in algae production, and the students learn how the ocean is very important as a source of resources in general, how the overfishing or non-sustainable fishing practices leads to a decline in fish stock, and how ocean temperatures and ocean acidification are on the rise. At the end, the player helps to define protected areas and restore the damaged habitats. In the third mission of the game, we have a highlighting on the importance of the ocean in climate regulation and biodiversity. Again, there is a coastal flooding as a problem in the beginning, and the player finds out that the flooding was occurred due to sea level rise. Throughout the game, the player finds out that fertilizers can contaminate the water and cause eutrophication. So a lot of different issues within the same mission. The importance of sewage water on the water cycle, and how the increase of CO2 levels leads to acidification, and which in the end affects the habitats. The main line in this mission is the ocean as a climate regulation, as a climate regulation machine, let's say. I should mention that in the end of each mission, there is a game concept section where the student can recap the main concepts covered in that mission, and with, for example, a theoretical paragraph where he reads about the issues that the mission was involved with some external links as well to external sources of information. Also, a quiz follows that, which is a multiple choice quiz about what the student has learned during that mission. The final mission is, let's say, a connection of all the things that the student was the player found out about during the rest of the 3 missions, and he needs to go around the island and compile
and approve a green plan for the island following specific directives at its place. The next tool that we developed is an ocean museum. And we started this by, the idea in the beginning was just creating an ocean museum in the classroom and documenting the results. This should work as a platform for students and educators to find out more about the ocean, to promote teamwork between the students and form a theoretical background for the pedagogical framework. What happens is that the students discuss the concepts in the classroom beforehand. So they decide on which subject they like most and make exhibits on that subject. And at the end, create a museum with all those exhibits where the rest of the students, teachers, and parents can go and see it. At the end, the teachers in the consortium gathered and documented good practices from the 3 museums that were built in Romania, in Italy, and in Greece. Following this, we figured out that there should also be a way to replicate this result to for other European schools. So we decided to also form a guide document, so a booklet, let's say, which would have all the necessary information for recreating or replicating this tool to other schools. We have a chapter on a theoretical chapter in the beginning, which goes over the theoretical knowledge on the ocean as a fundamental part of the Earth and the human societies. A chapter on the pedagogical framework of an ocean museum. Then a chapter on the practicalities of the creation of a museum in the classroom. And finally, a chapter with good practices for this tool as learned by the schools in the consortium. Finally, in the appendix, there are some recipes, let's say, for recreating some exhibits for such a museum, because again, we shouldn't expect teachers in a primary school to find out or create from zero all the exhibits. So we gave some ideas on that. And this can be used as individual cards or recipes for creating such exhibits. In conclusion, the implementation so far shows that these 2 tools enhance the engagement of students. It was very well received by the community. And we saw that students were highly involved in playing the game and motivated to contribute to the Ocean Museum. And some first indicators from the quizzes and questionnaires show an improvement of the students' understanding of ocean-related issues in the environment. We are planning to disseminate to wider audiences through multiplier events in all the countries of the consortium. One of them is tomorrow here within the framework of this conference. You're very welcome to come and be a part of it. And of course, we're going to have a final assemblance and analysis of the in-game quiz and questionnaires, as well as an assessment of the project outcomes and results. If you would like to find out more on this project, you can check mybluehome.aegean.gr, which is the website for the project. And if if you have any more questions, I can answer them now. Thank you very much.
The pace of the game looks very nice and easy. Do we have any questions? Maybe tomorrow at the specific session there are more questions to ask.
Perhaps.
Just to ask something. This is now it's a copy only in English, and just terminated through the project will be a version to other languages, and will be at the end freely disseminated.
Well, at the moment, so let's say the game is supposed to be translated in all languages of the consortium, so all 5 languages. The translations are mostly done by now, but the demo version that you can play online is at the moment, I think, only in English, or basically the game is translated, but maybe the quizzes and questionnaires are not yet implemented in other languages, but it should be done very shortly, as well as for the Ocean Museum Guide document.
It will be freely distributed to the public.
Yes, it's going to be freely distributed, and regarding the sustainability of the project, it's going to be cited on a server in the University of the Aegean, so it's going to be available in the future.
Thank you very much.
Thank you.
Can also not to be repeating, but now you can their restoration.
Let's start.
Dov'è Vieste?
So we will start in 2 minutes. We are in the 8th page in environmental management education. So we welcome you all. We have 3 presentations in this session. And we start the first one with Professor Prasakopoulos. And the title of the presentation is Plastic Pollution, Attitudes, Opinions, and Behaviors of the Public in the Area of the National Marine Park of Zagros. This is the study with the Paphos. You can see it here. And the floor
is mine. Okay, thank you. As you see, I am the last name. Responsible for this presentation was the first name, but unfortunately, fortunately, the 2 first authors just find a job at the OFIPEKA in Greek, in NECA, I mean in the Natural Environment and Climate Change Agency in Athens, not in Zakynthos. So now I'm in front of you to present the work of Konstantinos Moschopoulos and Dimitra Marmara mainly. Okay. As you have read in the first slide, the presentation is the study is relevant to plastic pollution. That is an emerged problem of global dimension and one of the most critical environmental concerns. About 85% of the litter found at sea, at the ocean, is plastic. Plastic litter pose serious environmental, economic, health, aesthetic, and cultural threats, including degradation of marine and coastal habitats and ecosystems that incur socioeconomic losses in marine-based sectors. In addition, plastic litter are also considered as threat multipliers. The study area is the National Park of the National Marine Park of Zakynthos. Zakynthos is an island at the Ionian Sea. And the study area is the Bay of Laganas that, along with the western coasts of Zakynthos and Strophades Islands, form the marine protected area of the National Marine Park of Zakynthos, and AMPHITHEATER, the acronym, is an area of prime ecological importance, characterized by particularly rich biodiversity of flora and fauna, and different types of habitats. Is one of the most important rookeries of the loggerhead sea turtle Careta in the Mediterranean. And in this Gulf, in the Gulf of Lagana, we can find 6 nesting beaches of Careta with a total length of 5.5 kilometers. Daphne and Crystal Beach are among the beaches we are focusing in this study. A part of the richness of biodiversity and the nesting beaches of Careta, the area has a high recreational and tourism pressure, and the Bay of Laganas is the center of touristic activity of the island of Zakynthos. This pressure, tourism pressurizes the current capacity of Zakynthos Island and causes degradation of natural environment. A lot of litter of waste are related to tourism, and these are recreational and the related recreational activities. And a part of the tourism that produces large amounts of waste in the island, we have also the problem of the mismanagement of solid waste
and lack of infrastructure. You can see in this figure, for instance, litter that the beach visitors left on the beach, or you can see also here a lot of waste across along the road of the city of Zakynthos. And here is the new landfill that was constructed in the island. And okay, yeah, a lot of the plastic of the waste found on the beaches, about 95% is plastic, is artificial polymer materials, and 23 of this plastic is single-use plastics. More than 7,000 cigarette butts, not bulbs, butts per year are collected by the people, the employers of the NMPZ at the 6 nesting beaches. The purpose of the study was to capture citizens' level of knowledge and their perceptions regarding plastics, and in particular single-use plastics, and to assess their intention to contribute to confronting the problem. In addition, the study focuses to collect information on the behaviors of beach visitors regarding waste disposal in the area of the national park. And for this purpose, a field survey was conducted by the Department of Marine Sciences of the University of the Aegean in collaboration with the management agency of the NMPZ in the context of the Interreg-Med project, Plastic Barter MPAs. The results of the survey were used by the NMPZ to design targeted measures to tackle SAPs in the protected marine area. The study yes, consisted of one questionnaire survey and one survey of beach visitors' behavior. So the field work, let us say, was conducted during the high touristic season in August 2021, and at the end of September of the same year in the wider area of Laganas Bay, as well as in the city of Zakynthos. It was applied, the questionnaire survey, to different stakeholders groups, residents, tourists or visitors, and local businesses. It was implemented by face-to-face interviews. The respondents were selected by convenience sampling. On the right side of the slide, you can see the 5 major question categories. Most of them were scaled questions, and some of them were only to answer yes or no. One of the first category corresponds to is relevant to the socio-demographic characteristics. Then the description of the personal experience with beach and marine litter, and assessment of the knowledge level of the different stakeholders group. The next group of questions is relevant to their understanding of the level and extent of plastic pollution in the area. The next group, the 4th group, is the self-evaluation on awareness level and readiness to change. And the last group of questions was related of their self-evaluation on tackling plastic pollution and use of alternative single-use plastics. 2 groups, as I said before, one, not that I didn't say that, 2 groups. Group A was oriented to residents and visitors, and we had 83 field questionnaires. And the second group was oriented to the business owners and we have and staff, business owners and staff, and we had completed 47 questionnaires. Then, regarding the survey on beach visitors' behavior, yes, was conducted the same time periods as the other the questionnaires, the filling of the questionnaires, and it was implemented only at the nesting beaches of Daphne and Crystal, and as well as the beach of Iosostis. All three beaches are found in the Bay of Laganas. And for each beach, a constant monitoring time was selected, and the behaviors of the visitors were observed by distance in order to avoid interaction of our team with the beach users. And the team of from the University of Aegean filled a record form where we had listed 10 predefined behaviors shown here. I'm passing to the results regarding the first group of questions that it was relevant to their personal experience with the beach and the presence of marine litter, and also to assess the knowledge level of the two groups of stakeholders. It seems from their answers that usually, very frequently, meet plastic litter on the beaches they are visiting, and the presence of marine litter, of plastic litter, affect their selection of the beach significantly, as you see. Among the different types of litter found on the beach, cigarette butts, for both respondents, for both group of respondents, was the major, the most frequent type of litter encountered. And after they follow plastic bottles or plastic cups. It is interesting to note that they gave incorrect answers regarding products containing plastic or made of plastic. As you see here, they do not know, the majority of the respondents do not know that baby wipes or that the cigarette butts contain a polymeric material. I'm passing to the second group of questions that focused on the understanding of the two stakeholders groups regarding the extent of plastic pollution in the area. Both groups recognize the ecological importance of the nesting beaches and support the need to protect nesting beaches. Also, they recognize the economic, significantly, you see here, the economic benefits of coming from the presence of the careta and the characterization of the beaches as nesting beaches. However, Group B are the business owners and the staff that is working on the businesses is more cautious. Both groups declare that single-use plastics represent the highest percentage of total beach litter if we sum these two categories. And also, they declare that are taking place, they say that the activities that are taking place on the beach are responsible for the marine litter we found on the beaches. Regarding the third group of questions that is relevant to where it is asked to self-evaluate regarding the awareness level and their readiness to change habits. It seems that both groups, with some differences, okay, are well aware about the impact of the single-use plastic on the environment and the hazard they pose. They said that they explored practices to reduce single-use plastic, the use of single-use plastic, yeah. And regarding the lower panel of figures, they declare that are ready to comply to the directive on ban of single-use plastics. However, if we see here, 1 out of 3 of the respondents is not familiar about the existence of the directive. So we have some contradiction here. And we continue with the same group of answers. Both groups say that the lack of proper waste disposal infrastructure is an obstacle to properly dispose of the waste that they are producing. And regarding the cost of the alternative products to substitute the single-use plastics, both groups say that cost a lot and is not easy to unify the use of these alternative products. And an obstacle that was pointed out by the business owners was the bad habits of the customers, you see here. This means that beach visitors leave a lot of waste on the beaches, and then this causes a problem to the business owners and the staff to collect and clean this part of the beach. And another problem is the difficulty on daily management issues that is related to the training of the staff. The area is highly touristic, as I said before, and many young people goes there for holidays and also works in parallel and stays on the island for 15 days or 1 month. And afterwards they leave, and so the business owners have to train if they are well informed, well aware about the problem of plastic and recycling and all of this. They have to train the new employers, because the people are coming and after 15 days or 1 month left for their country. They go back to their country and so on. The fourth group the fourth group of questions was relevant to the self-evaluation on tackling plastic pollution. It seems that both groups are active in confronting plastic pollution. However, you see here that a large percentage of residents and about 60% of businesses do not follow environmental friendly practices, and also very large percentages of both groups do not comply with the directive on ban of single-use plastics. And here is again one contradictory response. A lot of the respondents, the majority of the respondents, would like to participate in other actions to reduce plastic pollution, beach cleanups, etc. And regarding their behavior on the beach users showed environmental friendly attitude in general, They take care not to pollute. And the most common behavior that was observed is the disposal of litter in common waste bins due to the lack of recycling bins on the beaches. In some cases, waste disposal bins was likened from the beach, and the beach visitors collect all their litter to dispose them elsewhere. Some of them also gather litter that was already on the beach, exhibiting thus highly environmental awareness. A few of them read the informative material that was in some labels around the beach. 1 out of 10 disposed litter, 1 out of 10 beach visitors disposed litter on the beach. So based on the questionnaires, yes, meet plastic waste litter on the beaches. They recognize that the single-use plastics constitute the largest proportion of all beach litter. The presence of litter impacts their choice. It seems that the public, the respondents that were environmentally aware and recognized the impact of plastic pollution in the area of the National Park of Zakynthos, and are supporting the protection of the nesting beaches of the sea there, declare active in addressing plastic pollution, and they declare also that are ready to comply with the directive regarding the reduction of single-use plastics. However, a large percentage of both groups, and especially of the residents and the visitors, do not follow environmental friendly practices and do not comply with the directive on ban of SAPs. These are contradictory results, but it was not the first time that this was observed. Based on a report of UNEP of 2021, a survey that was conducted conducted in 5 Asian countries, so that the majority of citizens are concerned about plastic pollution, but they do not change their habits regarding the use of plastic products. And similarly, at the European level, according to a report of the European Commission at 2020, this report says that European citizens are well informed and concerned about the impacts of SAPs. However, less than half avoid to buy plastic products, to use plastic products, and 1 out of 3 of them only avoided to buy a product due to excessive packaging. So, okay, we have some limitations to this study, the small number of questionnaires that were filled. In addition to this I mentioned, there are some unmeasured biases that may result from the voluntary character of the sample, and also to our inability to reveal the characteristics, I mean, social, economical, cultural, that determine public perceptions. There are some suggestions for further research. One of them is to correlate the answers of the 2 stakeholders group with the findings of the marine litter concentrations that the NMPZ has collected in general, but also in the frame of this project, of the plastic buster MPH project, to investigate the ability of respondents to correctly or incorrectly estimate the type and the extent of plastic pollution that were declared and have a sign in the questionnaires. I'm passing to the final findings that highlight the need of more information to increase to improve the knowledge of the citizens on the sources, on the properties and the impacts of the plastic litter, and also to show them the solutions that are available. Also the training of the staff and the business source is necessary, and also to show them that preventing the waste generation and reuse of some products is more efficient and more appropriate solution than recycling. And finally, the fact, it seems that the fact here we have an area that belongs to National Marine Park of Zakynthos, but plastic pollution is there. This means that the fact that an area is classified as protected does not mean that is not threatened by plastic pollution. And this means that continuous monitoring and an effective response is deemed necessary both within and outside the boundaries of the MPAs, because some of the plastic litter found there is not necessarily produced on the beach, but comes from land or from sea, and even the adjacent marine areas. I'm sure that I have not time for discussion, but okay.
Knowledge on marine litter, so there's a lot of technology-free presentation today to listen to. So
yes.
I will leave one question coming from the audience. Thank you, Eva. Is the Marine Park authorities taking any measures?
Yes. This figure, for instance, and another previously, are measures that the National Marine Park took in the frame of this project. To avoid the use of single-use glasses, multiple-use glasses, or straws from, not from plastic, but from paper, I think. From paper. Okay, and also you see here ashtray with the label of the project to avoid this this figure with the cigarette butts on the sand of the beach.
Thank you so much. Okay, so we move to the next presentation. The title of the next presentation is Seagrass Comparative Analysis in Gera Gold in Delos Island, Greece, during 2015 and 2026 using remote sensing. The presentation is from Marco Welling, as from the undergraduate clinical part. So you can take 2 minutes, and that time I will be up.
Good evening, everyone. My name is Elena Markou, and I'm honored to be here at the HydroMediT conference. I am an undergraduate student of the Department of Marine Sciences here in the University of the Aegean, and today I'm here to present our research titled Seagrass Comparative Analysis in Gera Gulf, Greece during 2015 and 2023 using remote sensing. But first, let's talk about some general information on seagrass. Seagrass are one of the most important coastal habitats across the globe, providing oxygen, nutrients, and numerous vital ecosystem functions. However, seagrass faces several threats from human activities and climate change, making the need to estimate the seagrass percentage cover in diverse environment even more significant. But how remote sensing can help us? Remote sensing permits the study of extensive coastal habitats and reveal temporal patterns due to the high frequency of observation. The objective of our research is to assess the change of seagrass in the Gulf of Gera area in Lesbos over time using remote sensing, especially from 2015 to 2023. A few words about the study area. Gera Gulf is an allocated embayment in Lesbos Island, located in the south eastern part of this island. In the south and western parts of the Gulf, there are Posidonia oceanica meadows. The data used were obtained from the Sentinel-2 satellite. Sentinel-2 satellite carries the multispectral imager with 13 bands in the visible, where near infrared and short-wave infrared parts of the spectrum. Two Sentinel-2 level 2 images were downloaded with a spatial resolution of 10 meters, one from September 11, 2015, and one from October 19, 2023. The satellite images were already atmospherically corrected through the atmospheric correction applied by the European Space Agency. Now I will briefly present the methodology that was followed. The pre-processing stage was essential to ensure that the images had similar spectral characteristics. Several steps completed, including band spatial subset, resampling, and land masking. For the classification, we used the object-based method. During that stage, the following steps were performed: image multi-resolution, image accommodation, and supervised classification using 3 different classifiers: support vector machine, k-nearest neighbor, and random forest. Lastly, for the confusion matrix and analysis 22 ground truth samples were collected for each class, and then the extent and the difference between 2015 and 2023 was calculated. Now let's see an example of an image accommodation. You can see the classification before the classification. Our classification was object-based, meaning that the images were segmented into objects with similar spectral characteristics. The first image shows the study area landmasked prior to the image segmentation, and the second illustrates this post-segmentation. You can see there our objects. As I said before, there were 3 different supervised classifications using 3 different classifiers: SVM, KNN, and random forest, to compare them and identify which one has the best, that has the highest accuracy on mapping seagrass. In these images, you can see how its algorithm works. Let's now move on the results of our study. I will discuss the main findings and implications in the following slides. The confusion matrices showed that the SVM classifier had an accuracy of 72.50% in 2015 and 77.50% in 2023. KNN had an accuracy of 66.25% in 2015 and 76.25% in 2023. Last, random forest had an accuracy of 71.25% in 2015 and 70% in 2023. Consequently, the best classifier for mapping seagrass is the SVM
because it had the highest accuracy both in 2015 and 2023. On this map, you can see the SVM classification of Gera Gulf in 2023. Hard bottom is depicted in brown color. You can barely see it there. Sand is depicted in yellow, seagrass in green, and mud bottom in blue. The seagrass coverage over the Gulf of Gera based on the SVM classifier was estimated at 2,955,500 square meters in 2015 and 2,083,600 square meters in 2023. After analyzing the differences in marine seagrass, we saw that seagrass has decreased in the Gulf of Gera by 71,900 square meters over these last 8 years. This significant reduction highlights potential future trends as climate change and human activities increasingly impact the environment. You can see on this map the formations gained are depicted in green deep color. The formations lost are depicted in red color, and the formations that stay the same during these 8 years are depicted in green light color. As you can see, the most substantial decrease are seen in the western and southern part of the Gulf. While certain seagrass formations that remain stable are also found in these areas. The observed differences span the entire Gulf, with new seagrass formations primarily appearing in the northeastern part. In conclusion, the study reveals a decrease in the proportion of seagrass from 2015 to 2023, notably concentrated in the southwestern part of the Gulf, where the most significant reductions are observed. In order to ensure the accuracy of our results, field data needs to be collected and an annual monitoring of seagrass formations is required. Therefore, further research is proposed, which will be conducted over the next year. Last but not least, we have to highlight the importance of seagrass environments, protect them, and mitigate potential threats to their sustainability. Thank you for your attention. Now I'm sorry, I didn't hear you. 23. We know about how square meters has decreased, but to find the actual percentage, we have to collect field data. So we have to ensure the accuracy of our results.
maximum 10 seconds. But still is a loss. Question is,
If I'm understanding what
the two different years, okay, or this analysis of something like this 2023, or it is something that seems as probably also.
We use we use the images with the same spectral. So we had an spatial resolution of 10 meters. So I think the loss is connected to climate change and human activities.
Let's see, boundaries of data. This part of the graph, the slopes are very steep in relation to the other side of the graph. So I don't know if this has any impact on the analysis.
Yeah, I think definitely had, but again, I would say we need the field data to be sure about what we can see on this map. We use the Google Earth Pro to have an accuracy, and we saw the seagrass formations there. And I think for now,
Let's say very soon
for now, it's the best we have.
Okay, the message is like thinking about provisioning big data.
Yes, to have the yes.
If I can only add one thing, that we have the same data, exactly the same data in two different periods. We train exactly the same algorithm. So you use one algorithm and you check the result from these two measures. Without ground truth data, we will never be sure, definitely. But in general, we can see that in both use cases that we did once in Lima or in here, have a small decrease in the possible dynamicity. It's something really nice that we can search together with ground truth in a larger area. And to be sure, because this is closed environments, that it's a very nice case study that will be depicted in the program. So thank you, Alan, and congratulations. Okay, we've got the last one. The last presentation is coming from Philippe Vangelis, and the title is Spectral Characteristics and Detection of Marine Micas Formations using Sediment-2 satellite data. Allow me before Vangelis starts the presentation just to remind you that after We have the keynote speak there, so the keynote speaker is that's also what they do. So I think it's only you you have to be very good now.
We'll see about that. Okay. So thank you everyone for coming. And thank you for this amazing opportunity. My name is Vangelis Philippou. I'm an undergraduate student here at the University of the Aegean in the Department of Marine Sciences. Today I'm going to present to you our work in spectral characteristics and detection of marine mucilage formations using the Sentinel-2 satellite system. So marine mucilage is created due to microorganisms like bacteria and algae, and this phenomenon is further amplified by eutrophication. As a result, an aerated foam forms, and this foam aggregates in formations spanning from meters to kilometers. Marine mucilage poses as an ecological and economical threat. Ecological because it deters the sea column from sunlight and oxygen, and economical because it deters tourism and degrades fisheries. Furthermore, the area of study was the Sea of Marmara, more specifically the Dardanelles Straits and the Gulf of Gemlik, north of the city of Bursa. This area of study was selected due to the widespread 2021 marine mucilage event. The first instance of the event, according to our data, was on the 28th of March 2021, and the last instance was on the 6th of July 2021. Here you can see that the data were from the Sentinel-2 satellite system, which is equipped with a multispectral instrument, or MSI. The MSI is very well suitable for this application due to its very high spatial resolution and its 12 different bands. The data used were level 1 SED data, meaning that there wasn't any atmospheric correction done to them. So, two different dates were selected. The Dardanelles Straits on the 28th of March 2021, and the Gulf of Gemlik on the 19th of May 2021. In the bottom, you can see two different RGB images of the event. Basically, it's a subset of the satellite image. And those specific days were selected due to their high concentration of marine mucilage formations and their lack of cloud coverage. Here is the flowchart of the applied methodology. So the same methodology was applied for both satellite images. So the Sentinel-2 level 1 images were pre-processed using Aquatic for the atmospheric correction and land masking. The atmospherically corrected images were then used for the extraction of the spatial characteristics, and the KNN classifier was then used. So for the accumulation of the training data, as well as the data for the KNN for the spectral characteristics, a 5x5 pixel methodology was used. 5x5 pixel methodology, meaning that the selected target pixel was selected, and then a 5x5 grid was overlaid on top of it, and their values either extracted or used. The classification was done via the KNN classifier, and for the spectral characteristics, we choose two different classes. The first one was the deep sea water, and the next one was marine mucilage. As far as the spectral characteristics, three different classes were selected. The first one being sparse marine mucilage, the second one dense marine mucilage, and the third deep sea water. For the classification accuracy, it was calculated using 50 different accuracy samples for each class and for each image. So here you can see two different charts. The left one is of the Gulf of Gemlik. And here we can see that dense marine mucilage tends to increase from 492 to 704 nanometers, with a small trough appearing at 665 nanometers. After 704 nanometers, the values tend to stabilize. As in the sparse marine mucilage, we have high reflectance values from 490 all the way to 506 nanometers, with a small drop at 665, and then also the reflectance values tend to stabilize. In the left, we have a chart of the Dardanelles Straits, and here we can see that dense marine mucilage increased in reflectance from 492 to 704 nanometers, and with a small peak at 833 nanometers. As far as sparse marine mucilage, we have high reflectance values from 490 nanometers to 506 nanometers, with stabilization of their values after that. As far as the classification, we achieved an overall accuracy of 98% for the Gulf of Gemlik and an overall classification accuracy of 92% on the Dardanelles Straits. Errors in the classification appeared in both of the images, with overestimation of the marine mucilage formations and misclassifications of high reflectance formations. In the top two images, we can see the first one is an RGB image of the Gulf of Gemlik, and on the left is the product of the classifier. So we can see that in the center of the RGB image, there is have been an overestimation of the formation, and in the bottom two images, we can see that the bridge in the Dardanelles Straits has been classified as dense marine mucilage, as well as the small cloud. So, in conclusion, marine mucilage has increased reflectance from blue to red and near-infrared wavelengths, with reflectance values tend to stabilize after 704 nanometers. And there's also been a reflectance, we have also seen that the reflectance values tend to increase from dense to sparse mucilage, with an overall increase in reflection from March to May. The KNN classifier also achieved a 92 and 98% overall accuracy, with some misclassifications and overestimation of marine mucilage. So further algorithm refinement is needed. Thank you all very much for your attention.
Will affect the coastline this time. The Dardanelles Straits go north or mostly fuselage. The coastline affected by fuselage.
Yes, marine mucilage has been detected all the way to Limnos, actually. Yeah, but this instance wasn't used in this application.
So actually, yes, it went around Limnos, an island, due to the currents of the surface, and was very close to the coastline of the Limnos. And just before the authorities going and put something in front, we had the strong winds and waves that helped a lot in order to split it in small pieces and not having problems from tourism. It was on one day before the big event. By chance. By chance. Yes.
If I can also add something to your question. Yes, minuses was detected around floating minuses expression was detected around coastal Athenios Island, but at the same time we detected very high concentrations of chlorophyll A and suspended matter, organic matter, the whole of the northeast stick, spanning the permafrost. So a larger area was affected, but the floating formations were very deep side. That it was immersed and traveled around.
So since we are here, I would like to ask you a question. So we have seen that 1 year in a large area, having really long and very intense, but we haven't seen the following years. Did something happen that in the Gulf of Marmara and we don't have this phenomenon following years? You know?
Before this date?
I mean, the following years. Why we haven't seen that in the following years?
Now they don't talk to me to that. But we only This affected all the Marmara. Normally east and south the Marmara in Istanbul also, but more in other sides start to reach the Marmara, this is the end of the Marmara and temperature. And perhaps they say, I don't know if I don't following this problem, but I think you are very me too, and they both allowed on this subject, and I think they know more than me, but the media says mostly less ratio take track aside also, edit other logo and expose them.
Yes, yes.
Why did you select another one day how did their analysis proceed?
So usually when you apply your own atmospheric correction, you tend to have more reliable data. Like the whole atmospheric correction is way more, how to say, specialized in your image. Tends to, and also they use a more, usually they use a more accurate algorithm for the correction. In this case, it was I think the deep spectrum algorithm used.
Thank you so much. This is the end. Thank you for being here. As Professor Tuba said, we have a keynote speech in Amphitheater A, starting in 2 minutes. Thank you.